where is the disruptive angles in there. So I found myself now not going back 10 years. Almost every single job I've been doing, I really feel the benefits of working with researchers and working with the larger ecosystems and really building that the scientific framework and pushing the boundaries and converting things that we as an industry kind of not so comfortable with, which is creating IP and contribute back to the society. So today we have an amazing opportunity with Alan Turing Institute, and these are one of the best expertise in the country. We're very excited in here. And also we're working with Google, for example, on building new technologies in our cloud journey. We invented some of the ways to upload data, for example, onto cloud in a machine learning-based approach, and we want to open it, as an open source, even provide them to other parts of the customers to use. I want to probably mention one observation and two key success factors, in my experience. Just a very quick show of hands. Who consider themselves as academics? Cool. And who consider themselves as industry? Wow. And who consider them as both? Great. So that's one of my observations. I'm going to come back to that towards the end. The two success factors, I want to share. The first one really is a shared goal. And I think sometimes this is almost like the starting point of writing the paper. You put in the motivation. So that motivation absolutely has to be a shared between academics and between researchers and the startups and the company. So today, and that has to be around the customer and has to be around the purpose of what we're trying to achieve. So today, for example, in HSBC, we have 39 million customers across 67 countries. They are retail customers, they are small businesses, but they also large corporates and the government across the border. So we have 50% of them are digital population. 80% almost all the transactions are in this space, and we have about 190, 180 something petabytes of data. So the opportunity here is enormous, and for us, really providing our purpose, which is connecting customers to the opportunity. And today, those opportunities are in the space where we haven't managed to do properly previously. For example, in the digital, in the security environment, we want to provide a seamless signing process. For example, we use Face IDs and voice and fingerprint in about 20 different markets, and we have 350,000 per month live conversations going on, and those conversations we need to be a lot more tailored and relevant to the customers, more prompting, to what they're trying to do. And in the space, like cross-border transactions, we have last year enabled about $250 billion worth of transactions through distributed ledger. So these are all the innovation, which is a lot to do with machine learning and AI, the capability, but the purpose is to serve that market. And we got a really, really big challenge in our anti-money laundering, for example. These are enormous opportunity to do that. So that's one thing is we need to come all the way from how do we enable that connecting the customer to the opportunity, and from every stage, small roof shot, but also moonshot, eventually getting into where we want to be, as the shared purpose. The second kind of a key success factor is really around our own behavior change within the organization. So research is not really a one project, it's the behavior, and it's the behavior we gotta repeat all the time. It's very challenging. But on the whole, the change doesn't happen overnight and just because you have a project set up, and that way of researching, way of innovation is going to become our day-to-day life. So that's why one of the observations I've seen is a joint career path between academic and industry has really becoming a really success, career path, and people coming in from academic background had a real, career, and then we have a real need for those people to take part in our transformation. So that's kind of it does take courage to be in this space and to do research and innovation in a large corporate, especially, and it take a lot of courage, as we said yesterday. So. Thank you. That's if you have ideas and opportunities to work together, and we should have a chat. Thank you.
Thank you very much, Amy. If you've got any questions, please jot them down. There will be plenty of time for Q&A and a panel session afterwards, after the three presentations. So the next presentation comes to us from Lukáš Prush, who's our program director at the Turing for Finance and Economics, and is also based at the University of Edinburgh and as a Turing Fellow, and I'm probably forgetting other affiliations. Lukáš joined the Turing last year as program director, and he's going to talk to you about some of the cutting-edge research going on in the Turing that's relevant to finance and economics, and examples of existing applications as well as potential applications where the research could really make a difference. So, Lukáš, over to you.
Thank you, Nico. So good morning, everyone. Thank you for being here and coming for this session. So I'm, like Nico said, I'm a program director for Finance and Economics program at the Turing. I'm also a mathematician when I'm in Edinburgh. I'm trying to be, at least. And I want to tell you today a little bit about Finance and Economics program and give you an example, a couple of examples of things we want to do and the things we're doing. So I start with a vision. So we run the program to develop cutting-edge methods to foster financial innovation and deeper understanding of economy. And we want to make sure that the research we do benefits society. So that's our vision. That's the key thing we do, and the strategic objectives that we have at the moment in the program are: we want to advance economic data science. So that is a combination of economics with very rich data sources that are around us. We can do now extremely interesting things. We have example of the project actually of working together with HSBC, that we are looking at transactional data at the anonymized per postcode, and by analyzing financial activity, we can map that to online estimation of GDP. So now we can measure economy in real time. That could be very interesting from the perspective of policymakers, so they can understand how their policies actually impacting society, how they work. They are very interesting things. I think we are getting close. I mentioned a little bit more on that at the end. We are getting a little bit close in terms of the technology and compute that we have to start thinking and building a digital twin of economy, so as to model economy as it really is evolving. That would enable to do simulations and understanding, again, how various policies will change what is happening in the future. So I think this is very exciting. The other thing that we do is we want to promote responsible adoption of AI and data science in financial services industry. And we want to do that by trustworthy and scholarly leadership. There is a lot of noise out there. There's plenty of algorithms, plenty of methods, and plenty of challenges with data itself. And we want to make sure that financial services industry is really benefiting from these methods. So we want to drive this independent research that solves real problems and is taking into consideration. Oh, hello, we have another person attending a session. So there are great challenges. I'll mention a little bit more about that. There are great challenges in financial services industry in that the data is often non-stationary, is dynamic, is changing, and is very, very noisy. So that's clear differentiation from all the great things that we're seeing around applications of AI in speech recognition or image recognitions. These are typically static scenarios. And I believe that the third point is very important, that we want to drive fundamental research to tackle those two first challenges, to build up on the methods that we are seeing that are so successful, and tuning them to the right applications that work for the industry and work for the society. So there's a huge number of applications of when I say AI, I more mean augmented intelligence rather than artificial intelligence. I think we are still quite far from some of the statements that are put out there. Nonetheless, the applications are there, and we see that pretty much everywhere where there is a data-driven decision process involved, some sort of machine learning algorithm that allows to filter that data and is used. And applications and examples of that is, for example, a fraud detection and anomaly detection. So we have a group at Turing that specializes in building sophisticated networks of financial transactions, and by analyzing that, they are able to detect which transactions, which chains of transactions may be fraudulent, and we've been having great successes with that. The applications to the risk management, and including trading derivatives. So what is happening at the moment in investment banks, there is a big shift towards using machine learning methods, but the way those methods are being used are that you combine them with the risk methods that we know. We wouldn't like to give all the financial system to be managed by data scientists who don't have a background in finance. They don't fully understand all the caveats of finance and risks. So I think this is really, really important to get it right. And they're great examples. You can use the models that we know and understand, and you can use those models to train some of the neural networks to improve your risk management, by the same time making sure that you do understand the risks and you're not introducing a new risk to the financial system. Lending and investment advice, so this will be my running example, is a great application. Insurance, we've been hearing about amazing progress that has been done, that you have a small car accident, you walk out of the car, you take a photo of the damage, you send that photo to your insurer, and within 7 minutes you get the claim and money is in the bank account. So things are slowly happening. But of course there are great risks with that, because the same company that is paying your claim can also analyze your data and try to understand whether you will be willing to accept a smaller claim, because from other sources of data they know that you might be more vulnerable. So it's really important that we really think carefully about all those things that we can do. And risk monitoring of a financial system, of course, this is something where heavy machine learning and big data sets are extremely, extremely important, and we're doing this kind of work. The other point is shared data sets. So I think we need to move into models where we learn how we can leverage data sets that are at the moment in the different places. So I'm bringing here example of open banking that is coming as this directive that is coming in the UK, that is essentially forcing the largest retail banks to share their data with third-party platforms and new players. And the idea being that if, as a bank, needs to make a decision whether they will give you a loan and they want to look at your transactional data, typically each person will have 3, 4, 5 accounts at different banks. So it's inefficient if from the bank perspective, you can only access this one data set. You could do much better if you could get in access to data sets that other banks have it. So this is one of the big challenges that we'll be having in the financial systems. And we need to do that, and we're seeing that actually what is happening in Asia is that there are big companies that the financial system is much younger than here, and therefore there are financial companies that holds huge data sets, and that gives them a huge advantage. And ultimately, all we do is, like I said, should be serving a society that financial systems effectively will become more efficient, will become cheaper, and will increase the financial inclusion. What I mean by that by being able to tap on alternative data sets, the people that at the moment, say, have a poor credit history and normally wouldn't be able to get a loan, will be able to get it because we can understand that there are people we can trust by analyzing their mobile phones bills or whether they're paying rent on time. So these are all the things that we are trying to do. So let me walk you through a little bit some of the more concrete research methods that could be used. As an example, I picked the decision that we need to make about giving someone a loan. So typically, what's going to happen, so there's lots of talking about black box, and I want to shed a little bit more light into that. So typically, you start with data. So your data might be a credit history, number of credit accounts, income, expenditure and consumption patterns, mobile bills, and so on, right? So these are all the data sets you want to take into consideration when you're making a decision about giving someone a loan. So the simple models that were used in banks recently, or in most of the banks are still being used, are taking all those data sets, or even not all of those data sets, and trying to put the weight. So how much, say, credit history, how much impact it should have on my decision about giving a loan, or how much someone's income or ratio of the income to the amount of money someone is trying to borrow how much weight that should have on my decision. So these are simple models that we understand, and then we make a decision. And if someone comes back to us and wants to question the decision that he was given or not given a loan, then we can quickly answer, look, this is a model. You were not given a loan because of that. Of course, you can do something a bit more, something slightly more sophisticated, and what is happening is what I called handmade or engineered features. So it doesn't have to be just the income. It could be some relationship that you've discovered or has been discovered in the past, but something that we can understand. So these are what I refer as the simple models, where you need to come up with features before actually yourself. The neural networks, on the other hand, they are this fantastic device that you don't need to think much, you don't need to engineer any features, you can just press the button, and it's relatively easy to do it these days, and see what the network will tell you. So how that works, so this is a picture of the neural net. You feed your network with a data, and then what happens effectively, once your data is passing through the different layers of the networks, the data streams that are being fed are interacting with each other. So I don't want to go into details, but there is actually a nice analogy that I've read about recently that comes from the social physics. If you have to make a decision about something, you have some data set, so you have some information. If someone asks you, would you give that person a loan, then you could make that decision yourself, and then you will go to someone else to bounce that knowledge of a colleague and say, look, this is what I think, and that person might have a different information, and then will tell you something. So you interact, and for these interactions, you update your view whether you want to give that loan or not, and then that happens again. So as you pass through the networks, you interact with more people, and then update your knowledge. So this is very much the process that people are making decisions, and this is what is happening on the network. And I'm making here a little story, but actually, mathematically, the models that are being used in social physics to describe this type of interactions and models that are being used to train the neural networks are exactly the same. And recently, actually, there has been research to discover that. So we have much better understanding how the neural networks work, and this is kind of stuff that we do at Turing. So this is a network. We can train them at network. It will give us something, but the individual weights of the network has no meaning. In fact, it doesn't matter what those values are, and there might be different combinations of those values, and they still give you an answer. So that's your model. But the risk you're running, and probably all of you have seen that, is that this is the example from the Ian Goodfellow and his collaborators, that they've discovered that they took these big neural networks to train on images. So they've trained it, and the network was giving a good result. So X is the data, it's a panda, and the neural network was confident this is a panda. And you add a little bit more noise to the picture, so that to the human eye you still see this is a panda, nothing really changed. But the neural network now thinks it's a gibbon. So it's very easy to actually fool those networks. And this is a standard diagnostic that you should always run. So you have a model, you train your model, you think that model is doing something. But what you need to do now, you need to check that the data is being fed into the network might be just slightly different, and that might lead to completely different results. And particularly in the financial context, that could have terrible consequences, right? So we need to be careful about this. This is not to say that neural networks are great and they integrate lots of things, but we just need to be careful sometimes when we use them. But there is a plenty of other methods, actually, that are very good in dealing with financial data. So what I typically, like I said, when I say financial data, I mean noisy data streams that change with time. An example of research from Turing on that is coming from a group of Terra Lions and Nihao working on something called path signature. So this is a method that allows you to encode information from the stream of data. And they've been having great successes, and they've built all the algorithms using pure deep networks on Chinese letters recognition. So imagine you have an app on your phone and you draw a Chinese letter if you can, and you want the app to recognize the letter. So this is an extremely difficult task. And this algorithm the group at Turing developed actually is state of the art. And it has been used to action recognition, something I'll show you in a moment. And these methods can be used in actually fraud detection and anomaly detection and detecting anomalies in the limit order book in a financial market. So, oops, sorry. So just to tell you a little bit more how that works. So we have here a toddler clapping the hand, and the idea, the task is to be able to classify whether this is clapping a hands on some other action. So as you see on the right, you have this landmark. So you have those lines drawn on this video, and those lines are moving in a dynamic way, very much like financial data is moving in finance and interacting. And you're trying through that movement recognize which action that is. So this is much more difficult task than just classification of the images that are static. It's a very noisy. You will have 100 toddlers, and they will be clapping hands in different ways, at different speed, a different angle. This is very easy for us humans to recognize, but this is very difficult for machines. So you can do this action recognition. I skipped that, running out of time. And the interesting thing about this method is that it's extremely good in extracting those patterns, and is actually explainable. You are able, after getting your answer, you are able to say which data streams, which interactions of data streams actually have the input out, play the most important part in the output. So what I'm trying to say is that while neural networks are there and are great, there are other methods that we understand quite well that can do a very good job, and they do not suffer from some of the issues of the neural nets, and are more suitable for financial applications. So there is, like I said, there's quite a bit more of different things. I skipped that. And I want to go back a little bit to the thing when I said about economic data science and building a digital twin of the economy. So this is the little game that was created by DeepMind, where blue and red dot represent agents, and the green stuff is an apple, and the agents are getting scores for eating the apple, and they also have a laser beam. They can knock out the opponent. They're not getting scores for that. And Google was interested to understand whether the agents will collaborate. So whether they will share the apple and they both be happy, or they will start fighting using a beamer. And so they started playing that game, and they started increasing resources and decreasing resources, and also increasing intelligence of the agents. And it turned out that, as we can expect, when the resources, so the amount of apple is going down, and the intelligence of the agents is increasing, the dots became quite aggressive, and they started fighting. So the reason I'm showing this is that there is actually quite a lot of research going into something which is called mechanism design. And so the idea being that once you have a system, like in economy, and even if you know that your agents are selfish, and there's nothing you can do about this, you can still try to design incentives in such a way that the agents will ultimately reach some social equilibrium. And I think, this is just a little game, but I think we're getting closer with amounts of data that we're having and with amounts of a compute that we have to start doing this type of simulations to understand things that are happening in the financial markets and the things that are happening in our economy. And so this is where I see the research heading in the next years. And the very last thing I want to do, I want to advertise that there are lots of questions about use of ethics in finance, and at Turing we are organizing a conference that will take place in 16-17 of July with FCA and ICO, where we will be discussing ethical use of the AI tools in financial services industry. So thank you very much.
Lukasz. Next, again, please keep your questions, write them down, keep them warm. Next, we have Vincent Branch who's the CEO of Excel's Accelerate division. His expertise focuses on innovation and insurtech, and he's going to talk to us about some of the use cases going on he's been working in his company with his team.
Thank you very much, Nico, for the introduction. So I'm Vincent Branch, head up or joined to set up the innovation function at AXA XL. Today I'd like to share some of the case studies, some of the real-life examples around how we're driving commercial applications. In particular, I'd like to share our payer-to-partner strategy around how we're thinking about how we can blend trust and bringing more trust into financial services and insurance. And actually really driving a sort of better innovation culture. So first of all, as an introduction to AXA. So within AXA XL, we specialize in ensuring the complex, difficult, large risks. So if you think of earthquake, hurricane, marine, aviation, cyber, those are typically the types of risks that we're ensuring for a whole range of, in particular, corporate clients, SME clients, and mid-market clients. So the way we structured innovation across the division is we have XL Innovate, which focused on equity investments, where we partner with those companies and we participate in taking part in those organizations. We then have Accelerate, which is the area that I lead, and we're driving partnerships and driving commercial opportunities together. And then thirdly, we have digital, which is driving operational efficiency and how we can use that to be better in how we operate. So to give a feel for Accelerate, as mentioned, we're focused on the commercial opportunities. There's really three areas in which we focus on. The first is around developing new distribution opportunities. And the way that we're doing that is actually looking to partner with alternative distribution, in particular the technology companies, in how we can bring products to market in a very different way with a very, very different experience. Again, going back to payer to partner, is we don't want to lead from an insurance transaction. We want to think around a range of services that we can offer to those clients to help them run their business, to help them be more successful. The second part of that is actually developing the propositions. How do we wrap those services around that, and how do we develop those services in a very, very different way to how we sold insurance in the past? And then the last is thinking about our technical capabilities of how can we make a step change in our technical capabilities around how we underwrite, how we price, how we risk manage, and doing that in a completely different way using the new technology that's available. And I'd like to give you a couple of examples of those. So let's just talk about how we approach innovation. So we run a portfolio of experiments, typically around about 15 to 20 a year. But every single one of those involves an external partner. We specifically want to bring them into the organization. We want to be able to partner with them, help them develop their services, but bring those new perspectives. But we also work directly with the business. But actually, we go beyond that. We actually get the business to lead the experiments. And that's part of the cultural change that we want to drive. And we found that being very, very successful in thinking about how they can actually look at understanding the new technology, get involved in that, but actually have skin in the game of driving innovation within the organization. And then really the last part is every experiment we do and every partnerships we do, we're really looking for shared value. What do I mean by shared value? The first is the client has got to be at the forefront of what we're doing and how we're designing those benefits. Second of all, we've got to be very transparent about what we're going to get out of that. And we've got to share that with our clients. And thirdly, there must be a societal element to what we're doing. And that shared value underpins all of the partnerships that we have. So typically the experiments are very small and focused in what we do, and we test those in a short time frame. But actually, every experiment and every partnerships we do can be scalable. It has the potential to be scaled. We typically don't touch anything that is perhaps bespoke to a particular business unit. We want something that could be used across the wider division or the wider group. And then our challenge is working out those successful experiments and then working with the business to decide how we best approach that scalability. So there's really two examples I'd like to share with you. The first is around mobile autonomy. We've had a strategic partnership with an organization called Oxbotica. You may have seen them on some earlier stages, and they were also here last year. So they specialize in developing mobile autonomy software. They create the brains that go in an autonomous car. But actually, what's really interesting about them is their technology could be applied into forklift trucks at one end, all the way to standard autonomous vehicles that can go on the roads, all the way up to complex construction equipment. So actually, the breadth across the industries is really, really interesting to us, which means actually we can help the broad scale of clients that we work with. So what we've been doing with it, we're part of a UK consortium of bringing driverless cars to the roads by the end of this year. But actually, the reality is we've been running driverless cars on the UK roads for the last 18 months as part of actually testing and thinking about how we can think about the risk management aspects for that. So our role within that is we're embedded within a whole range of partners in developing that, but specifically we're looking at the risks of when you're looking at particular journeys, particular risks, we're thinking about the characteristics of those journeys. So for example, how often has that car done that route? How well is the algorithms and the AI trained for those areas? What's the weather conditions? What's the traffic conditions? How risky are those journeys? And we're blending that together and helping that to make decisions around what's the best journey to take. But actually the real goal is to actually embed part of that risk decision making in with the software. So it's an actually integrated solution so the clients, the partners can make decisions over those trade-offs between performance and risk. And that integration is a really critical part of that. It can't be something like a traditional insurance we do at the end of the year, we do once a year. It's got to be in the actual technology itself. The second aspect is we've also been working with our partners to actually design a new autonomy proposition. Autonomy risks are completely different from any traditional insurance risks. You've got your standard liability, you've got your standard bumping into other cars, but actually cyber is really prevalent. Product liability, the actual aggregation of risk to the specific components in those sensors and cars is completely different on a scale that we probably won't see in other sectors. So how do we address those? So within Accelerate and working with our external partners and working with the business, we've brought together all the right experts to address that. And so we've developed a global autonomy product, and we did that in 3 months, from concept all the way to getting that product live in the market. And so we now ensure a whole range of autonomy pilots and trials across the world. And we're actively seeking to work with those partners. We need to be able to learn and work with those partners to really help that product evolve. And that's not where it's going to stop. And then the last example is around cyber. So clearly there's a huge amount of relevance for cyber in what's been talked about in the last couple of days. So we've really developed a new cyber product. Again, we launched this in a very short period of time. But specifically, we're thinking about how can we help small businesses. And part of it is how we can bring educational content around what is cyber. But then the other part is actually how can we bring content and like a dashboard to say what are your risks that are specific to your business, but actually what steps can you take to actually address those risks. So the focus isn't actually on selling the insurance, it's actually on helping them address their particular security and cyber needs. And this is something we're working with a whole range of distribution partners in thinking about how we can enhance that and have that a wider proposition. And the last thought I want to leave you with, again, is going back to the payer to partner. We need to have a change in mindset about how we think about providing insurance and services and a wider piece. And again, that comes back to the motive as to why we're doing that. And at the heart of what we're trying to do is insurance isn't about payment. It's not actually about protection. It's actually about helping clients grow. It's about helping clients thrive in this incredibly complex changing world and thriving with these new risks in these new environments. Thank you very much.
Thanks very much, Vincent. We're now going to set up for the panel discussion, and I'm just going to hand over to Lukasz, who's going to chair.
So thank you both for very interesting talks. One of the things that I think came about from both of you was saying that the world is changing, those technologies are here, we can use them, but, well, thank you. But how, and you both said that, at the center of that should be customer or should be client. How are you ensuring that the customers and clients are fully benefiting from those technologies? With help of organizations like yourself.
How's that? Yeah, I think, it's very loud now. So the customer-centric, I think, is absolutely in the center of how do we bring the technology to people. Now, for example, in Hong Kong, we notice people, social payment is very, very popular. So one of our, solutions is called PayMe, and it's becoming, it's only a couple of years, and it's becoming one of the most popular what's the most popular mobile payment solution. So people use it because they're really helping them to discover new things and also very convenient. So those are from the technology point of view, tons of machine learning stuff has been putting in and using transaction data as well as external data to make that really accurate. But I think the technology side is easier to identify. On the behavior side is harder. Now, for example, the financial well-being is a very important concept in the financial services, and it's a reasonably abstract concept. How do we bring the behavior into that so people actually realize what they do make the major difference? So we've done some research around customer behavior, and actually we find out being a saver or a spender make more difference in terms of your financial well-being status than your income between 20 to 100,000. So there's a huge gap of our understanding, and once we got that, we actually putting in a lot of things which is prompting the saving behavior, and just make people more aware of that has made a big difference. Because that side, I think, is softer, but have a bigger impact on the financial, activities and our well-being.
So I think there's a couple of angles here. So I think one is around the actual education content we bring to our partners and clients. I think we've all got a really critical role in doing that, and that's very, very relevant for retail and personal lines, but it's just actually as relevant for small, medium businesses in how we do that. There is a big gap in how some of those sectors are being serviced around understanding those risks. So we see that as the forefront. And then the other piece is around the motives for doing that. We've got to be really clear about why we're doing that, and what's in it for us, but also around, we want to be working with people that are excited about solving some of these problems for our clients.
Thank you. And what's your approach as an organization to some of the ethical aspects of using technology? So, of course, you were saying that your motivation is to help, and you're doing all those amazing things, but that challenges as bias hidden in the data. How you ensure do you train people within your organization? What the processes do you have as a market leaders to make sure that we get it right?
I mean, it's a really great question, and this is something that is certainly evolving very fast. I mean, just a couple of observations to share first, and then actually I'll give some examples around the processes. I think the first is around who you work with. So it's around your people, and it's around the leadership from the top, around what is expected, around how we think about our clients and what's important and what isn't. It's got to come from the top. And in our organisation, it absolutely does come from the top. We were very explicit about not underwriting and insuring certain sectors in the energy sector around coal mines and various other things. We felt that was a really important stand to take. The second thing is we also expect the same of our partners. We also expect, and it's the style in which they engage with us around what's important to them. We want them to have a shared interest in our clients and who we're working with. And then the last part is, how do you think about those processes? How do you actually think about embedding those things? So if we think about privacy, we're thinking about privacy by design. Actually, this is something you do at the start of everything you do in what you're working on. This isn't a process you do at the end. This is something you have to think about, and if you're sharing any data, the first thing you're thinking about is how can you manage that risk? And then we've got specific committees and governance of where we sort of go through on a deal-by-deal basis, where we actually look at all those risks and get approvals for those.
I think a very similar approach as from a ethic kind of a decision has to come from the policy as well as the processes and our understanding from the data perspective. So from the data, for example, we do have lots of bias, from the data itself, the algorithm itself, the ability to interpret. I think we turn to get a bit deeper and have gradually building capability to understand it. So there's clearly an issue around this, and we're trying to enhance our machine learning-based approach versus rule-based or simple algorithm, as you explained early on, to have a better governance around it. So that's one side of the equation. We must have capability to do it. And many of the bias actually introduced from our people prone to more automated decision rather than the behavior. So that's a new set of decisions we need to make. How to push things and advertise, and what's our value proposition to make sure people are aware of the certain biases maybe come from more automated decision. And then on the policy side, I think this is one of the absolutely on top of the whole organization's mind. It's about how do we putting in the right consideration from the very beginning by design to take that into consideration, the fairness, the transparency, the principles. Lots of government already putting up the principles. At HSBC, we also have lots of work going on in that space, and also education. So there are staff education if you're frontline, or if you're obviously in the risk space, or if you're a technology space. We all have trainings now putting into place. Some of the executive training also starting to put in. I think the awareness at the staff level, everybody get an understanding of what machine learning and what the data, that in the first instance, what that impact to their now day-to-day talking to the customer is absolutely key in that ethical consideration.
Thank you. I think I fully agree. I think it totally needs to come from the top, and you need to start from the very beginning to cultivate this right behaviors. I mean, example of that is actually financial markets that are being regulated for the last 200 years, and then still bad things are happening. A financial crisis is showing that regulators is not always the only answer. It's just culture, and cultivating this right culture from the very beginning, I think is a key. I want to move a little bit into the topic of trust and innovation. And so one of the examples that I have that I'm referring to the context of the trust of using black box algorithms that are there is the context that every single time we take a plane, is not that many people actually understands the details why it works, and then somehow we trust that everything will be fine because we trust that the people that build the plane, they have the right knowledge. And how do you see that is being developed in the context of machine learning within the organization?
I'll give a relative. So a couple of things jump out. Actually, the first is around accountability. If I was a structural engineer designing a bridge, it's a huge responsibility and risk. But I think that engineer fully recognizes the risks that they're making and the sort of professionalism required in making that decision, and the QA required in coming to that decision. If I think about data science, we're potentially putting the responsibility on one person to build hundreds and hundreds of bridges. And I think we've got to bring that sort of broader perspective to the accountability on what these algorithms are being used, which will then actually make sure that we've got the appropriate QA processes and assurances and governance around that's proportionate to how the algorithms are being used. So I think that's the first thing. And then I think the second thing, I know it's been touched on a lot in the last few days, is the transparency of the decision-making and the methodology around the algorithms. It just isn't good enough that we don't understand how some of the methods work or how we've come to certain conclusions. Personally, I believe we're on a slippery slope when we go down that path, if we think about biases and discrimination and various other aspects. Yeah,
I wouldn't repeat, but just add one thing, I think, is the purpose. we need to be absolutely sure, the reason we want to use that data, the reason we want to use the technology is for the right purpose and for the right thing. And I think more questions need to be asked at the beginning to really build that trust. I think that's, one thing probably in addition to all of the key components. Yeah, you just mentioned.
And so how do you cultivate this innovation culture, how you make sure that you have that right balance between research, innovation, and trust within your company?
Okay. I think one thing probably doesn't help is trying to segregate people who can do research or allowed to do innovation. It's a very big behavior, and I think it's a particular mindset and also the scientific approach, putting in a hypothesis for every single person when we do our jobs, and that is how we should approach the problem. Looking at it from a more scientific point of view rather than gut feel, for example, and then go very deep and then not afraid of tackle a complex problem, for example, and have an alternative approach. Those kind of behavior, they are not titled by a particular group or individual, and then also not always necessarily to do with your research background. I think that kind of a mindset and also practice, together in a very real scenario, just practice. I think absolutely everybody could be part of that, and I think that's where you're going to see a culture change and people value different opinions and value the IP and what we can do and pursuing something excellence. That would be the key for driving research and innovation in a day-to-day basis.
Amy, some excellent points. And actually, I build on that first one, which is, well, we have a mantra at AXA XL, which is innovation is everyone's responsibility. And what we mean by that is it's similar. Is actually we want everyone to think about that and be, to actually explore, discover. Again, if we think about all the underlying traits we had as children around sort of discovery, we lose that as adults. So as organizations, we need to again foster that culture of, you learn by mistakes. That's the key way that we learn. And then the other important aspect again is we need to bring in external perspectives. Again, if I think about insurance, one of our biggest challenges is how do we bring diversity to what we do? So it's critical that we broaden out the skills, the experience, the backgrounds of people into our organizations, and we work with different people to really bring that sort of different culture.
Thank you, that's a great answer. And I have to share that, with similar perspective from Turing. Turing is a place where you bring researchers from different fields under one roof. There are no walls between departments of economics, computer science, maths, and statistics. And this creates incredible research and innovation environment where people talk together, exchange knowledge, and I fully agree. That's really good. The very last point that I want to touch upon was something I've mentioned during my presentation, is sharing data. So we are entering this phase that we all feel that we can benefit from having shared data sets and various organizations being able to tap on that knowledge and that data that you might not have. How do you, as an organization, are you prepared to do that? Are you already doing that? Do you have some examples where you already started using some shared data sets with other organizations or other companies?
Yeah. I think open banking, as you mentioned, is definitely a big initiative. It definitely helps when we look at the data from a broader perspective, but I also want to bring in another element of it, which people quite often miss. So when I was in Singapore, telco as an industry already starting to put different telco industries together, for example, and so you have a geolocation, and then they really want to encourage the ecosystem to leverage on that data sets. However, I think is a couple of years into that initiative, and I would say the real benefit has yet to be seen. And one of the key challenges in there was actually interpret that data is a lot harder than most people realized. So we turned to focus on getting the data out, but actually the ability to really interpret and understand with the domain and really with the right purpose of using that is often the critical stuff to leverage on that. But yes, we do definitely very keen on using data from all the sources. We also publish some of our trading data. They are already published. I think the ecosystem for sure is the where we can get a much better insight and we can make a much better decision, and also in the secure manner. That's the way of the research into privacy preserved method of sharing or encrypted format, so we don't have to see the details, but you can make a better decision. For anti-money laundering is a classic example. We would benefit a lot from it. So I think yes, the sharing data, but also focus on understanding and the core competency around using those data.
Okay. So thank you very much. Thank you, the audience, for being with us. Thanks.
We next are going to have a session focused on the role of research in the UK economy. We're just going to get our panel ready for the session, so bear with us. Of course, if you want to move on, fine, but you're very welcome to stay, and hopefully more people will join as well. So, so you just give us a couple of minutes to get the stage ready. think we're ready to kick off the next session. So whilst we focus on finance and economics and the role of artificial intelligence in that sector in the first session, this time we're going to turn towards the broad role of research in the UK economy. And I'm just going to introduce the chair for the next session, who in turn will introduce the panel. So Priya Guyas will be the chair for the session. I first met Priya when she was British Consul General in San Francisco in the US, and in the early days of the Turing back in 2015. And what was wonderful about that connection is that Priya introduced us to a number of US organizations we're still in touch and collaborating with today. Priya, besides being on the Council of the UK Research and Innovation, her career has been going from strength to strength, and her focus very much around helping tech entrepreneurs thrive. So I'm just going to hand over to Priya for the remainder of the session.
Thank you so much, Nico. May I ask the panelists to join me on stage, please, and I will introduce them as they come up.
Thank you.
Yeah. Wonderful. Perfect. So starting on your right, we have Professor Sir Mark Walport. Mark is the Chief Executive of UK Research and Innovation, which is the body responsible for the public funding of research and innovation. And it has just celebrated its one-year anniversary. Previously, Mark was the UK government's Chief Scientific Advisor, and before that, Director of the Wellcome Trust. Until 2003, Mark was Professor of Medicine and Head of the Division of Medicine at Imperial College here in London. Next to Mark is Dr. Hayatun Salem. Dr. Hayatun is the Chief Executive of the Royal Academy of Engineering, where she has worked since 2006. She comes from a background in biochemical sciences and previously served as the Committee Specialist and Specialist Advisor to the House of Commons Science and Technology Committee. And then we have Professor Sir Adrian Smith. This is actually his stage because Sir Adrian is the Director and CEO of the Alan Turing Institute. Previously Vice-Chancellor of the University of London, he also served as Director General Knowledge and Innovation in what is now the UK Department for Business, Energy and Industrial Strategy. So I hope you'll agree with me, there's no better panel than this to discuss the important topic of the role of research in the UK economy. So to kick off that discussion, I wanted to start with actually asking you, Sir Mark, not least for the benefit of some of the international visitors that might have joined us today, just to talk a little bit about the landscape for UK research on that wonderful moment, which is the happy birthday to UKRI.
Yes, well, we're one, so we can just about toddle. But actually, let me just say a little bit about UK Research and Innovation, because it is exactly the right organisation for what we're talking about today. So what we're bringing together is over 100 years of the research support in the United Kingdom. And in 2015, Paul Nurse did a report looking at the coherence of our research and innovation system and recognising that we don't live in a world siloed by disciplines in the same way anymore. The opportunity to bring together the 7 research councils, so everything from the Medical Research Council through the Engineering and Physical Sciences Research Council through to the Social Sciences and the Arts and Humanities, was really important so that we can actually tackle issues in an interdisciplinary fashion. And if I had to summarise in 3 words what we're all about, we're about knowledge with impact. So the other thing that we bring together is Innovate UK, which Priya is very involved with, because it's one thing to discover knowledge, but then the important thing for society, particularly since there's £7.5 billion a year of taxpayer money going through UK research and innovation each year, is that that knowledge has impact, be it cultural impact, be it impact in the knowledge economy. It's that whole range. And we're only going to achieve that if we work coherently. And when I look through the sort of breadth of our portfolio in AI, data science, autonomy, it's sort of breathtaking. It's everything from work with the Alan Turing Institute and the British Library, living with machines. So understanding the history of previous revolutions, using modern technology to do it, and learning the lessons which are still relevant today. How can we deliver public services better? So we have a program on AI and data science for engineering, health science, and government. And that brings together a series of government departments. And then I think probably the most important thing of all, in truth, is skills. At the end of the day, we will flourish or not depending on our skills. And so a very important part of our activity is centres for doctoral training. So training PhD students. As a part of the sector deal, we have 1,000 new PhD students in AI in the broadest sense. And I think it's worth reflecting that although I don't think this is about the sort of whole spectrum of education, maths A-levels are absolutely critical to this. And although the numbers are going up, there were about 90,000 entries to maths A-levels in 2018. And it brings into focus gender issues because equality, diversity, inclusion is really critical to this. And it's 60% men, 40% women roughly were going in, doing maths entry. And further maths, it's only about 17,000 people that do further maths. So that's critical to the pipeline. We kick in when it comes to postgraduate training, and I think it's one of the most important things we do.
Thank you so much, Sir Mark. One of the great sort of visible embodiments of what you referred to there as the AI sector deal for the UK government is, of course, the Turing Institute. And I'd love to maybe get you to talk a little bit, Adrian, about how the Turing Institute came about and what it is that is driving your role, particularly in relation to the broader UK economy.
Yeah. Before I get on to Turing explicitly, can I just add a bit to Mark's overview of the UK funding research landscape? Because we actually run a twofold system. There are the considerable sums of money that go through Mark and UKRI, but there are also considerable sums of money that go directly into the universities. And for the overseas, this is the so-called dual support system. There is a funding stream, in a sense, which the universities earn based on past performance, whereas what UKRI are dishing out, in some sense, is funding in terms of research promise for the future. And this is a very important way in which the system is balanced in the UK. But the relevance to the Turing story is what we have got in the UK is a tremendous national asset in our universities. Our universities are, to a large extent, the research engine. Okay, pause. Turing was set up, it's been about 3 years old now. It arose from a suggestion from the great and the good who composed the Council for Science and Technology, which advises Prime Ministers and Chancellors of the Exchequer from time to time on what's coming over the horizon that the UK needs to take seriously. And it was a letter from that Council for Science and Technology at the time when David Cameron was the Prime Minister and George Osborne was the Chancellor of the Exchequer that basically went as follows. Okay, we've always had data and we've always had problems and people have always mucked about with data to get insight and solve problems, but there's something new on the block. It's just the sheer scale of data that's out there, coupled with the scale of computing power, which in a sense then creates a playground for doing clever things. And we call those clever things by different names, data science, AI, machine learning, whatever. But this is coming over the hill, the Council for Science and Technology said. We in the UK are terrific at the basic disciplines in mathematics, computer science, software engineering. We should have an institute that attempts to bring this together at scale so that we somehow harness, convene, and broker more than the sum of the parts of the expertise within the UK. So the basic way, one of the key ways in which Turing functions is through university partners. We now have 13 university partners. We don't own hordes of research staff. We have some research software engineers, we have some young research fellows, but the main academic hitting power are secondments from our 13 partner institutions. And we call these Turing Fellows, and they might turn up for a day or 2 days or come from blocks of time across multidisciplines. And we, like a production line in a sense, it's not quite like this, we assemble them to attack big problems. We don't deal with small problems, so ambition. Let's revolutionize the NHS. Let's totally transform sectors of our public life using the data that's out there. So at the moment, I think we have getting on for 400 Turing Fellows. Thank goodness they're not all there at the same time, because the space only holds about 250. But they are the main academic resource, and we convene them around challenges which may be to do with the economy, may be to do with health, defense and security, new emerging fields in a sense. The whole of engineering, civil engineering, infrastructures, that world is being changed by sensors and data collection in almost every realm you can think of. So in a sense, via Turing, we've invented a new discipline, data-centric engineering. So we're looking at scale, at big challenges. We have non-university partners who come in for specific reasons, and I think maybe later we talk a bit about the corporate world and how it engages with the world of research. But we have strategic relationships with banks, with computer manufacturing and design companies, and with a whole range of healthcare and other companies. So Turing is still a startup in a way. This is a vast field. We're boiling the ocean if we're trying to solve all society's problems, but essentially we're harnessing UK brainpower in this area to attack major challenges for the public good. Will that do for now?
That's fantastic, and we're going to come back to some of those themes in a second. I wanted to start talking about one of the perhaps tensions that's out there when we're talking about research in the UK economy, which is a potential either or between the value of fundamental science, fundamental research, and then research that can perhaps have an application in the broader world, and one might lead that to say has a more significant impact potentially on the UK economy. Hi, Arsene, I wondered if you might be able to start to address that point and give us a sense of your perspective on that.
Absolutely. So, of course, the short answer is it's an entirely symbiotic relationship. But just to frame it a bit more, coming from the Royal Academy of Engineering, we are particularly interested in research that is closer to market, closer to end user, and, of course, innovation, by which I mean the process by which we get the fruits of research out into use through new or improved products, services, processes. And that's a really, really key way in which we capture the value from these incredible strengths in our university system and in discovery science. And going back a bit, I think there has been a perception that in the UK we tend to particularly prize our very great brains who are active in the end, that's sort of often termed pure science or discovery science, that's somehow a more sort of noble endeavor, perhaps a higher intellectual content. And of course, the lived experience of so many who work at that nearer market and that user-inspired section of our research community is that working with industry, working with patients, working with other sorts of end users, policymakers, is an amazingly rich seam of really intellectually challenging research questions. And of course, it's also really, really important that we look at some of the huge societal challenges we face. Adrian referred to a few just now. We have today's announcement around the net zero emissions target for carbon emissions for 2050. And of course, you think about the kinds of tools that we might need at our disposal to really help us achieve that. So I'm really pleased to say that we do see changes. It's a perception that persists, but in fact, we've seen a real breaking down of some of those silos. I think that the fact that universities are increasingly focused on impact as one of the indicators of research excellence has made a difference. I think the fact that activities like CogX and lots of other activities have helped to really celebrate the accomplishments of entrepreneurs who are commercializing and delivering value from our huge achievements in research, that's made a difference. And I also think the fact that we've got people who are coming into the education research system now, a new generation who are perhaps more motivated by social impact than some of us were when we entered the profession, is also changing the culture. I think when you look at funding, which is another of the areas where we've probably historically had a bit of a challenge, so the perception is that in the UK has not necessarily invested as much in that later stage research and the innovation piece as much as some of our competitors or comparator countries, depending on how you want to look at it. And of course, there, the Industrial Strategy Challenge Fund has been a hugely important development. So, it's a really significant new direction for the UK, and we have to make sure that's successful. But I do think there is some residual concern over the amount of funding that is kind of left over for those entrepreneurs and SMEs in particular who are out there doing fantastic activities that could be more research intensive, already are research intensive, and their ability to access funding that isn't attached to some sort of directed funding program. So I think the last publicly available stats, apologies if I'm not up to date, were that for 2017-18, Innovate UK's budget had around 6% available for open calls. Obviously that means we've got a squeeze on the ability to fund that kind of bottom-up innovation, entrepreneurial-based research that's happening. And I do think in that context, the fact that we're looking to our longer-term relationship with Europe and potentially loss of access to some European funding schemes that have been really quite important to some of our most innovative high-growth SMEs is important. So the SME instrument, which has been a really great source of relatively unrestricted funding for some of those really innovation-intensive SMEs, is something we need to think very hard about.
I'm going to come back to the issues you've rightly highlighted about later stage R&D, but Mark, please.
I just want to pick up this very artificial distinction between discovery and application. So Abraham Flexner in 1939 wrote an article for Harper's Magazine, which was entitled "The Usefulness of Useless Knowledge." Now, we really wouldn't be sitting in this room having this conversation if not for the contribution that quantum mechanics made to our understanding of the inner workers of the atom, and we wouldn't be here having this conversation without CERN, because it was Tim Berners-Lee who's solving the problems of communication and data handling that went with CERN, who invented the World Wide Web. Fabiola Gianotti, the Director General of CERN, was over talking at the Science Museum recently and made those points really very effectively indeed. We have to continue to discover things, but what we also have to do is, wherever possible, make sure that they are made useful. And we don't know when things are discovered whether they're going to be useful or not. And so an important part of our activity is actually funding researchers, as Adrian says, in universities predominantly, but across the whole sort of system, to discover stuff. And I just want to pick up your point rather specifically about Innovate UK, which is that Innovate is moving effectively all of its response-made funding to open competitions, recognizing that the Industrial Strategy Challenge Fund, which has grown, is fairly directed. But again, if you look at the Industrial Strategy Challenge Fund, Next Generation Services, Audience of the Future, Transforming Construction, Transforming Food Production, in every one of these, AI, data science, autonomy is intrinsic and important.
Adrian, I think you want to come in.
Yeah. Can I add to the "we wouldn't be here unless"? Since you're in my Turing pavilion, we wouldn't be here without Alan Turing. And if you think back to the wartime Turing, the cracking of the Enigma machine, etc., there's a twofold thing. One is abstract algebra, and the other was probability theory that were brought together to win the war. So this division between pure and applied, I think, is nonsense. When I was an active researcher, I proved theorems in the morning and I did applied things in the afternoon. It's not a right distinction. So put it to bed.
Can I just one more little lob in there? I wholeheartedly agree when it comes to sort of the philosophical distinction that both of Sir Mark's and Sir Adrian's comments were absolutely spot on. But nonetheless, the topic of today's panel is research in the economy. And I think when it comes to looking at how we capture value in the UK, actually looking specifically at that nearer market activity and that commercialization, entrepreneurial, business investment is absolutely pivotal. So it's not so much as to, about the inherent relationship as just making sure that we are setting ourselves up well to make sure we maximize value capture in the UK.
I mean, I couldn't agree more with that. But I mean, of course, it's really important to recognize that one of the most important things that we supply is people with skills. So it is, and it's not actually all people who've done computer science degrees or maths degrees, it's engineers, it's physical scientists, all have a very important role. But you are absolutely right. If we don't turn this stuff into application and benefit for society, we're missing a trick. And our role in UKRI is to fund before the market kicks in. And that's always the challenge for government. We shouldn't be substituting for private investment. But at the early stages of the development of companies and applications, there is a market failure quite often, and that's where we have a critical role.
So I think the question that Hayaton raises is a really good one to transition into, which is, how do you measure the impact of research on the UK economy? And Mark, I know this is something that UKRI thinks about a lot, not least given the £7.5 billion of taxpayers' money that supports research. So how do you measure it? How do you get that value for money for the taxpayer?
Well, I mean, you can't reduce it to a single number, but at the end of the day, we are part of the government's industrial strategy. Part of that, for example, is a target to increase UK R&D investment to 2.4% of GDP. Now, actually, if you look at what that comprises, about a third of that in most OECD countries is public investment and 2/3 private. So we have to work with business to make sure that we leverage, as it were, industry and business R&D. But at the end of the day, it's about actually measuring outputs, outcomes, and ultimately impacts. And I think historically, to be honest, there has been a bit too much focus on the inputs, how many grants, how much money. What we are collectively buying as taxpayers is the products of the research, the products of innovation. And so it is, I think, about the people that we train and educate, what happens to them, the discoveries that are made, how are those discoveries turned into benefit. And so it's a complex mixture of narrative and metrics. And to be honest, it's not a trivial problem. Measuring a £7.5 billion portfolio, which is split into thousands of grants, it's not an easy thing to do. But I think what we have to do is look at it rather specifically and not think we can come up with some single number that somehow says success or failure. But I think critical to all of us is that at the end of the day, we have a thriving economy and we have all the benefits of this technology. And I think there is another critical issue, which is diffusion. And so in the UK, the gap between the most productive and the least productive companies in almost every sector is quite broad, broader than in many other OECD countries. And so I think the question for everyone in and around this is that most people here are working at the cutting edge, or indeed in some cases at the bleeding edge. But the real question is, how do we diffuse it through the economy? And 80% of our economy is a service economy. The service economy is being absolutely transformed by all of this technology, and indeed the blurring between manufacturing and services is becoming ever greater. So it's not really a valid distinction anymore completely. So I think there's a big challenge there, which is how we make sure that all of these benefits diffuse not only in business terms, but also across the country. We have a very uneven economy.
Hayaton, did you want to come in?
This is a topic I feel really personally very passionately about, and I'm glad as well that Mark, you put right up front there this false dichotomy. We talked about false dichotomy between pure and applied research, but the same applies to our kind of industrial categorizations, services, manufacturing. The world has moved on. And one of the activities I'm involved with is the Made Smarter Commission, which is the UK's initiative to try to make sure that we really advance and maximize the opportunities associated with Industry 4.0. So it's a partnership between government, so our Secretary of State for Business co-chairs alongside Jürgen Meyer, who is the Chief Executive of Siemens UK. And I see that as, in a way, a great complement to some of the absolutely world-leading research that happens both at the Turing Institute and across our university base. Sometimes, I think we rightly celebrate the huge strengths we have in the brightest minds and the frontier research we undertake. We are actually world-leading in many of the disruptive technologies that are going to shape all of our futures. And I just wish we'd perhaps talk a little bit more about how we're going to make sure that those technologies are really deployed at scale across our public and private sectors, across the whole of the UK. Again, this place I mentioned is super important. Because ultimately, I tend to think that the bigger determinant of whether we're net beneficiaries or not of these new technologies or these disruptive technologies is going to be to do with our ability to adopt and deploy, because that's what's going to determine our competitiveness, our productivity. And there are two big components to that are related. You've talked about diffusion. I might talk about adoption of existing innovational technologies, similar point. Lowering the barriers for SMEs. Not all of that long tail of lower productivity companies are going to be interested in adopting some of the technologies that are associated with Industry 4.0, but we have to be better at reaching those who have the potential to deploy them, but don't currently have the capacity or the bandwidth to do so. And the related point is skills. So skills to me is such an important piece of this picture. And I really think we have to move beyond this notion that skills stop at the point at which you've stopped your formal training or education. So it's not a conveyor belt. You make a decision at 14, and then you head off along, whether it's FE or whether it's HE, possibly do a postgraduate qualification, et cetera, et cetera. We have a situation now where it's estimated that 80% of the workforce of 2030 are already out there. They've left full-time education. We have a situation where the pace of technology change means even those people who are expert today are going to have to move their mindset to have a sort of more continuous upgrading of skills, rather than a sense, well, I've got my qualifications and I just need to keep building a bit of experience behind me. And this is a major challenge for the UK. We don't have a culture, and we don't necessarily have very good systems of delivering those skills, helping organizations and individuals who can self-identify as being potentially disrupted by technology. We don't have really good systems to help them tackle it. So Made Smarter is doing a part of it, but there is so much more to do. I could keep talking on this all day, which you probably don't want me to do, so I'll stop at this point.
Adrian, please.
So not to overlap with many of the things that have been said, but just to point perhaps to a few other elements. Particularly in what's happening in data science and AI, this is something that would not have been on the agenda or in the minds of those who were educated 30, 40 years ago and perhaps have senior management positions. So just one of the things we've done at Turing, which has been really eye-opening, we've held breakfasts for chairs and CEOs of FTSE 100 companies, and basically gave them a shock and tell story of what's happening in this world and the disruptive potential effects, with a view there, hopefully, that it trickles down through big organizations and people are put to seeing what that really means for them. The other point I would make is there really is a potential tension that we can't hide between excellence and place. Where you have concentrations of expertise, or where over the years big facilities have been put on campuses, you can't suddenly replicate that in a poorer or disadvantaged area of the country. So I really do think, and I know Mark knows this really well, it's not just it's skills, it's everything, but the notion of place and how we get a more equitable joining in of the great stuff that we're all interested in here, I think remains a big challenge. The other thing I would say is we are playing in an internationally competitive environment. So we have to understand not just the metrics of how we measure outcomes, but what are the metrics that actually attract inward investment and interest in the UK. And then you come back to this question of pure versus supply. It's actually the strength of the research base and the strength of the universities in the UK, which over and over comes up as a big reason why people want to invest and be in the UK. And the final thing, when you're looking at journeys to impact, the timescales can be very different in different areas. I mean, in some sense, the revolution that really kicked off in 2010, perhaps with deep learning algorithms as a transformation, That goes back ultimately hundreds of years, but certainly 1950, Turing's paper on Can Computers Think? You know, so journeys can take much longer in some arenas than others. In biomedical sciences, genomics, maybe it's faster. I mean, the whole world runs online now, and online encryption owes its basis to 200-year-old theorems in pure mathematics.
Mark,
it can take a long time in some.
Would you pick up specifically that point about place?
Absolutely. So, I mean, the first thing I'll say is that I don't think a place agenda and an excellence agenda are in conflict. And I'll explain what I mean by that. So firstly, I don't think you could simply drop a Turing Institute into every town in the country. It wouldn't work. But actually, when you look around the country, excellence is very widely distributed, but focused in different parts of the country. And we actually have a Strength in Places fund, which is a very specifically place-orientated fund in UK research innovation. And what we're looking for is 4 things to come together. So firstly, an area of business strength. Secondly, we're looking for allied strengths, typically in more than one university, because providing different sorts of skills. The third thing we're looking for is local support, because there needs to be local skin in the game. And the fourth magic ingredient to get clusters developed, because that's really what we're talking about, is leadership. But when you look across the country, for example, there's a tremendous compound semiconductor cluster in South Wales, where there's business, there's a new catapult that's been put there, there's great strengths there. You look across the whole of southern Scotland, and there's a photonics cluster. These things developed organically. Look around Dundee. It's one of the most incredible life sciences clusters in Europe. Indeed, it's world class. And these things have sprung up around the country. And so what Strength in Places is about finding those real nuggets of excellence and building on them. But where I agree with Adrian is you can't simply, as it were, put a nanotechnology institute in every part of the country. That won't work. But Andrew Whitty, in about 5 years ago, did a piece of work looking across, mapping where the strengths are. And that effectively everywhere in the UK has got strengths. What we have to do is catalyse and build on them. And I mean, Adrian might say something about that. I think one of the important things about the Turing Institute from its foundation is that it sits in our National Library.
Yes,
and it seems to me that's a really interesting point.
Yes, no, I'd love to come back to that, but Hyton, I knew you wanted to come in there.
Okay, I'll keep it very brief. Just, I very much agree with what you said, Sir Mark, because actually you look at engineering excellence, it's perhaps more widely distributed across the UK than many other areas of research excellence. And I take great encouragement from that, and I think that to some extent this is also about our will to be creative and to consider an inclusive role as a leading funder, for example, as being a challenge to make sure we find creative ways to couple investment to factors other than where we have existing research strength in particular disciplines. And I'm sure that's not what you're referring to, Sir Adrian, but in the context of engineering, you see, for example, where large companies are investing, having a huge bearing. So there's an interplay between that and our international trade activity. The UK has a very highly internationalized research base, and particularly when you look at business investment, extremely highly internationalized compared to comparator countries. So we need to be smart about thinking, how do we really sell the UK to some of those countries and companies who might be able to help catalyze new centers of excellence? How do we make sure we contribute to local strengths and skills that may not be about the postgraduate research workforce, but maybe about the ability to work alongside robots in factories in a more advanced way than currently might be the case amongst that particular workforce. And to use our innovation assets, perhaps in a slightly bolder way. So innovation assets can be as simple as we have a hospital, which could be really a focal point for making sure that we use novel approaches to genomics for medicine or for autonomous systems within hospitals, and you create new clusters based around existing assets. So I just think it's going to take creativity, but I'm more optimistic about our ability to couple place and excellence.
So let's come back to the point that Mark very rightly raised, which is actually cross-disciplinary approaches are one of the keys to unlocking the future economic potential. And he rightly noted that, of course, the Turing Institute sits in the British Library, just very close to where we are now in King's Cross. Would you tell us a bit about the importance of that cross-disciplinary perspective to what you're trying to achieve there?
Let me take a specific example that what would be the big worry in the whole world of, you know, robots and algorithms and the rest of it? For some of us, it would be a rerun of GM crops or MMR vaccines. The Daily Mail splashes a headline, "Algorithm kills 500 old age pensioners." Me, maybe. What do we really need to think about so that we don't get into that space? And the terminology we tend to use in Turing what would it mean to have safe and ethical basis for algorithms? Now, as soon as you get into that kind of space, this ceases to be a purely technical problem. You need to understand ethical issues, you need to understand societal responses to things, behavioral responses, and you need to build that, in a sense, into the whole programs. But of course, there are big techie things. If you think of the things we worry about, biases, unfairness, lack of transparency, explicability, to get into those things, which are really core issues pervading the whole scene, is enormously multidisciplinary. It's not a purely techie thing. So one of the things we do, we run these data study groups where 80, 100 PhD students from all over the country come for a week, and they get problems pitched at them at the beginning of the week, and they vote which ones they want to work on, and then they try and solve the problems during the week. Now, all these problems are impossible, but because they're young PhD students, they don't realize that, so they go away and solve the problem. So it's all fantastic. But the first Monday morning, a huge amount of the time is spent teaching them about privacy and ethical and those kind of issues. So it's at the heart of the Turing thing that we are multidisciplinary, interdisciplinary. And one of the things that Mark alluded to earlier, a major project, Living with Machines, which in a sense is the digitization, the archive of the Industrial Revolution in the UK, led by humanities scholars. So we have everything from English history, social science, behavioral science, ethics, and the odd mathematician.
Fantastic.
They're all odd, yeah.
So I wanted to turn to something that I think has come out in all of your remarks so far, which is the importance of equality, diversity, and inclusion as we're thinking about achieving the full economic potential of research in the UK. I was particularly struck by a report that came out about 4 months ago saying that there's only 0.1% of university professors who come from a black female background, and that the majority of those had experienced discrimination at some point in their career. And this obviously comes in so many forms, and gender is one that's often talked about. I'd love just to talk for a few minutes, and I'll give everyone the opportunity to comment on how they're thinking about this really important issue of ED&I. And Mark, do you want to talk about it in the context of UKRI, first of all?
Absolutely. I mean, this really is a central issue for us. And I think it comes down to, if we're going to make progress, we've got to look at it from a broad culture aspect. In other words, it's not simply about how you interview better. It's actually about creating a work environment where talented people from all backgrounds can prosper. And so it's about everything. I mean, obviously, it goes back into the education pipeline and making sure that the pipeline itself delivers much better representation, and you can see universities changing in that respect. But it is actually about making laboratories the place where people from all backgrounds want to work. And so when I was at the Wellcome Trust, we did some work asking in terms of gender, the gender balance was about 50-50 of people doing PhDs, but then when you look 4 or 5 years afterwards, that gender balance had changed very extensively. And so we asked people, what is it that made you stay or leave, men and women? And actually the factors were very similar for both, though the effects were more marked for women, that they didn't like the culture of the laboratory. And so we have to tackle that. So it is actually about harassment and bullying, because if you don't crack that, it is actually about how we fund. So if you give people very short-term grants, that's much harder than if we give people the time to actually explore interesting and difficult problems. There are just so many different aspects to it. Jennifer Rubin, who's the executive chair of the Economic and Social Sciences Research Council, has taken on this as a very specific issue on behalf of us all. We are taking an evidence-based approach to it because, of course, everyone comes up with solutions, but the question is actually, is there any evidence those solutions are going to work? Because I think that's a big challenge. But, I mean, frankly, we're not, I think, going to make progress unless we tackle it in a very multidisciplinary way. And I just would go back to, you know, if here we're talking about subjects where maths is quite important. And yet when you look at the ratio of women to men doing further maths A-level, it's 72% men to just under 30%, 28% women. And so it is, there is a pipeline problem. This is what the social scientists might call a wicket problem. I'm not sure I like the naming, but I mean, it's really important. It's not going to be solved overnight, but it's got to be solved a lot faster than we're doing it at the moment.
And if I may put my Innovate hat on for 1 second,
Yeah.
I think one other example that's worth highlighting is the work they've done to showcase the role models of women in innovation, supporting them both financially, but also giving the visibility to those amazing women who are doing fantastic, innovative work in startups and scale-ups across the UK. There's been a wonderful initiative recently to put purple plaques, as I'm sure you know,
Yes.
in schools where these successful women went to give the innovators of the future the role models to aspire to, which is, I think, is wonderful.
And it's worth saying that the gender diversity of the executive chairs of the councils is much better than it has ever been.
Excellent. Please, Adrian.
Some of this depends on where you start the conversation. So clearly within universities you can change cultures and practices in terms of promotions and leave and so on. But just going back, I did last year a study on post-16 mathematics education in the UK, and I just give you one simple figure from 2016-17. Of all the people who did GCSE mathematics and got a grade A, and then went on to do something, let's say quantitative or physics, maths, whatever, something in that space, of the girls who got a grade A, only 50% went on to do something, let's call it related. Boys, 72%. Now, since that's your start pipeline for, as Mark has alluded several times, A-level maths, A-level physics, which is the pipeline through to the thing, unless you get that right back there. So I think urgent studies to see what it is that is causing that kind of bifurcation at the age of 15, 16.
Adrian and Mark, you've rightly identified a lot of the sort of cultural and contextual challenges there. There's one big area that I'd maybe ask you to touch on, Hayatun, which is that purely and simply, the research that we have is surely going to be inferior if we're not having an inclusive range of people at the table. So talk me through how you're thinking about that and where you think this could have a positive economic impact on the UK economy.
Well, I think if you, I'm sure lots of people have heard of Caroline Criado-Perez and her book Invisible Women. Really, it's the Bible if you want to look at all the case studies of where there's been a negative societal economic impact from lack of consideration, in that case of gender, in the context of all sorts of aspects of public and private life. And she makes some very powerful points around medical research, clinical research that I really hope people in our funding bodies are having a good look at. And as somebody who works in engineering, which unfortunately has a rather severe diversity deficit, so we have a profession that is 12% female, 8% black and minority ethnic engineer, it's something that I talk about a lot. I mean, obviously, I come from underrepresented groups as well, and that perhaps makes me especially interested. But one of the things we do a lot at the Academy is we work with companies, and within a company, one of the first things that needs to be done is you make the business case. You create that narrative that links it to the things that the board are going to care about. If I'm really honest, I think if we're in the business of disbursement of public funding or deployment of public funding, I think the moral case has to be front and center in our minds along with the business case. Because I don't really know what the argument against prioritizing diversity and inclusion across all of that activity is. I struggle with that. So I'm really pleased to see that there has been a much greater embracing of the issue across research and innovation. I think Again, if we look back into the past, there's been a bit of squeamishness about the idea that, we might be having to compromise on excellence. How can we believe that a university system where less than 1% of professors, if you include men as well as women, are black, is the result of a system that is where excellence always prevails? And so I would say that all of us in leadership roles in the research and innovation community need to push ourselves very, very hard about the extent to which we are setting ourselves and others the right level of ambition, how hard we're pushing to deliver on that ambition. It's normal now that if you're in a major company, your executive team will have diversity inclusion metrics embedded in their performance appraisal. It'll be there, it'll be determining their bonus. It'll be there as one of the, the metrics for the assessment of the chair of the board. I really ask, have we come that far when you look at research and innovation? I think there is more to do. I think there's more to do in the symbolic things. Does every single government panel review have diversity represented? Does every single speech given by a senior person across government have, balanced representation of excellence in all its forms of diversity? I don't think we're there yet, if I'm really honest with you, and I feel really passionately about this. I'm thrilled with the announcement that was made at the start of this week around the 18.5 million in AI skills, which had an explicit focus on a proactive mechanism to enhance the diversity of those who are going to possess those skills in the future. So, thinking more creatively about allowing people to transition in at a later stage of their career. We do need to look at the pipeline, but I'm also not prepared to wait until we've grown everyone from scratch. So, we're going to be working for a very, very long time. Let's bring people in, diversify at different stages. So, I think, that's just a sort of little flavor of the sorts of things that I would see from my vantage point.
Yeah, absolutely. So I wanted to make sure that we had time to talk about one other really important theme. We've talked quite extensively about the role of taxpayer money and government research in the UK economy. I wanted to talk about the role of corporate R&D for a second. You talked at the beginning, Adrian, about, I think, 13 industry partners that you have at the Turing. How important is that role of corporate R&D and indeed that intersection between universities, government-funded research and corporate R&D?
It was actually 13 university partners, but I mean, if we tot it up, and Nico could hold his fingers up for me down there, all the kind of industrial products, we have about 30, 40, 50. But there isn't a one-size-fits-all narrative. Big companies are in these things for very different reasons. Mark and I were at a dinner last night, in fact, where, in a sense, the corporate conversations and the business conversations are in the context of a campus like Harwell, where you have big facilities, world-leading things like synchrotrons, which act as a magnet for companies to work around. At the other end of the scale, we have a major strategic partner, which is one of the world's biggest banks. And why is their interest in interacting, say, with Turing? Largely, I would say, access to fabulously clever people. And why would we be interested in them? Well, the data that a major bank has is sort of microsecond information about what's happening in the economy, what's happening in people's heads. And so that fusion, I mean, there has to be something that brokers at the interface. If it's a big engineering company, it could be facilities, it could be expertise in robotics or whatever. So Turing may be particular, but in our case, it's basically the fact that we can broker and convene the mass of the brain power that the UK has in the arena. And as a one-stop shop, you can come and access that and start conversations. I think that would be our draw. The world we were in last night, it would be the fact we've invested in world-leading facilities that act as a magnet for corporates. But the narratives are very, very different for an engineering company than for a pharmaceutical company. In fact, they all want to talk to Turing because they've all got data. But
Please, Hayatin.
Thank you. Just wanted to share some insights from a piece of work that we've been doing, which is based around talking to CTOs or budget holders for R&D amongst a whole range of companies across engineering and other science and technology-based sectors, both large and small, and asking them at this particular moment in time, what are the factors that make the UK a great place to invest, and what are the factors that are influencing whether they might disinvest in the UK or upscale investments outside the UK. As I referenced earlier, we have a system where 16% of our business investments in R&D is from overseas sources compared to, say, 8% in the US, 7% in Germany, I think. And that means that we have to consider the UK in its global context. And what we see is there are some things they love about the UK. So they love the quality of our skills base. There are some challenges over quantity, but the quality is superb. Similarly, the quality of our university research base, and nearly all of them really value their partnerships with universities. Thirdly, they love what Innovate UK does. So actually some really positive feedback for you and your colleagues at Innovate. Areas where they felt we fared less well compared to other countries. The ability to have a joined-up conversation across government. So the consolidation of the different funding councils and Innovate within UKRI is an important step forward. But of course, there are many different government departments and aspects of the public sector that will be factors that may influence the decision. And the kind of the story that we were told is when we look at other countries, they are make it easier to market themselves to us as a very attractive destination. They're doing the hard work of joining themselves up so that it's easy for us to see the offer. So that was one thing. Another thing that they said was that late stage, development, very kind of large scale development deployment funding was a bit of a gap. Acknowledging Industrial Strategy Challenge Fund may help to plug that. And then the third area that I think is also really interesting is procurement. So those of them that interface with government in the context of procurement were not overly complimentary about the experience of doing so. And I think it's a long-standing observation that in the UK, we do not maximize the fact that I think it's something extraordinary like 14% of GDP, an equivalent amount is spent on procurement in the UK and in public procurement. And that there is this huge opportunity to leverage a proportion of that to drive innovation and the sort of the risk appetite and perhaps skills of those people who are involved in public procurement mean that we don't maximize that opportunity, particularly compared to countries like the US.
So let's talk about that international element. It is so fundamental. Mark, do you want to talk a bit about that from your perspective?
Let me just say something about company R&D at the moment, because we're going through an extraordinary industrial revolution. Companies that don't innovate are not likely to do well. And so, it's a mixture of adopting new technology, but it's also inventing new technology, using it in imaginative ways. But I think it's important to understand that the nature of company R&D is changing a bit as well. So we don't capture all of it, I think, with our current statistics. We're used to measuring R&D in the traditional sectors, aerospace, pharmaceuticals, heavy engineering, automotive. But if you look at the companies around this part of the sort of knowledge quarter of London, innovation, research and development is in their lifeblood. And I think the other thing to recognize is that actually what's happening is big companies are often outsourcing their R&D by corporate venturing and by actually surveying the landscape of small companies and then effectively buying the ones that do successfully. And I think one of the big challenges actually for the UK is we are great at starting really innovative companies. We're not so good at growing them. And I think that's one of the big challenges, and that's where we need better access to capital. There's lots of capital floating around the world. It's actually about making sure that it sticks with our good companies here and enables them to grow. But on the international point, just look around here. Any decent laboratory, any company has people from all over the world. And so if we are to continue to thrive, we have to continue to be global, we have to continue to work on a global stage, we have to continue to collaborate internationally. This is not optional, it's critical to the future of the UK.
We're almost out of time, but I know we have one burning question at the front. So please, there's a mic just coming in. If you wouldn't mind, just a brief introduction.
Yeah, my name's Steve Podmore. I'm working on a project called Transform Global to create a sustainable development bank to address the SDGs. My question really is about the provision of long-term finance and risk capital at scale to deliver high-impact innovation and high-impact activity. And my question is really, what is your comment on the work of Mariana Mazzucato, where the public purse is providing this money, but surely the public purse should get some sort of upside, which could help fill some of the funding gaps that, Doctor, that you referred to. So any thoughts on the provision of innovative finance to financial innovation for the provision of long-term capital?
Mark.
Well, I mean, I think firstly, you have to ask the question as to why the public is investing. And we're investing actually we have to invest with a greater risk appetite than private investors, because if private investors would do it, we shouldn't be doing it for them. So one of the things I think we need to be doing is catalyzing private investment. But I think it is an interesting question as to the extent to which the public should get a direct return as opposed to the indirect return, which of course when companies grow, they employ people, those people pay taxes. And so there's a quite clear public benefit as well as the new services and products the public get. I mean, Innovate UK has explored and is exploring at the moment loan schemes. So I think it is a live question that we ought to be aware of. I don't know what the right answer is, but it's clear that the public must get a return from that £7.5 billion a year it's spending. And it does go to the question of making sure that return diffuses across the country.
I wish we could continue this for another 2 hours, but sadly our time is drawing to a close. It has been an absolutely fascinating discussion, so I hope you'll join me in thanking Sir Mark, Dr. Hoyerton and Sir Adrian for their contributions to this fascinating topic. Thank you.
Thank you.
Thank you.
to what is the last session of the day in terms of speaking session at the Alan Turing stage. For those who weren't here earlier, my name is Nico Gernio. I'm the MC, and I'm also the Director of Partnerships at the Alan Turing Institute, looking after all our industry collaborations amongst a number of other things. This final session is going to focus particularly on policy and the impacts, the positive impact that data science and artificial intelligence can make, and how it can help transform the area of policy. And to present to you today, we've got two fantastic speakers, and they're both from the Turing Institute, which is even better from our perspective. And the first speaker, which I'm going to invite on stage, is Omar Guerrero. Omar is a computational social scientist and is one of our Turing Fellows. And I'm just going to let Omar just introduce the first topic. Thanks, Omar.
Thank you, Nico. Can you hear me? Can you hear me well? Okay. So thanks everybody for coming to this talk. I will talk about a project, a research program, which is trying to help governments to reach the Sustainable Development Goals. And like many programs in the Turing, it started with an academic conversation between myself and my collaborator, Gonzalo Castañeda, from one of the leading think tanks in Mexico. And from an academic conversation, it was picked up by the United Nations Development Program, which asked us to adapt our methodology to the Sustainable Development Goals in order to advise countries. So in this process, we have gathered a few allies, especially from the Mexican government, like the presidency and a couple of local governments, the Ministry of the Treasury. And that is because they are really interested in knowing how could they prioritize their resources across the many different policy issues that are covered by the Sustainable Development Goals, something not trivial at all. And the way we do this is first by thinking about development as a process, a transformative process. So you can think of this process as a machinery that takes on inputs, perhaps capacities, human capital, resources of all sorts, and it produces development. And usually countries measure this development through development indicators, like the ones that track the SDGs. And the interesting thing is that when you look at international agendas, like the SDGs, all countries are trying to align to them, and they are measuring the SDGs through these indicators. But what about the inputs? So let's talk about one of the main inputs, which is the resources that governments put into public policies that will make these indicators move. Well, those inputs, which would be, for example, public expenditure data, actually we don't know too much about them. You will not find data sets telling you how much countries are spending in all the indicators that are tracking the SDGs, at least not in a disaggregate level that would be useful to provide policy advice. It's quite an interesting problem, because that means that if we want to understand how the input transforms into the output, we need to model this engine, this machinery. We need to model the process of development. In particular, we're going to model the policy-making process. So we have development indicator data, and we're going to try to reverse engineer the process to infer how governments are prioritizing the resources to reach development goals. So what we developed is a computational approach to model this process, and the process is actually quite complex. So if you speak to a policymaker that is involved in this, in helping their countries to reach this agenda, you will hear different stories about how difficult it is to actually reach the goals that governments plan ahead of time. So let me give you my mental model, and this is basically the spirit of our approach. Suppose you have a central authority, which could be a treasury, for instance, and the central authority is tasked with allocating resources across different policy issues. Here I'm representing these policy issues as different SDGs. So suppose the government allocates resources to quality of education, SDG number 4, with intention of improving it. Some agent in a public agency, it can be a minister or the entire agency, is going to take those resources and produce policy and transform those indicators. Okay, this sounds very good. But any policymaker will tell you that in the process of transforming resources into policy outcomes, you have inefficiencies. So you can have inefficiencies, for instance, because of lack of capacity, because you have badly designed contracts with the companies that you hire to perform some projects, or simply you can have plain corruption and diversion of public funds. That means that there is no one-to-one mapping between the resources to the outcomes. And we need to understand that process. We need to model it, to take it into account. And obviously, this is hard to observe in data. You cannot actually see it. So governments, well, they try to monitor the performance of their indicators, and they try more or less to evaluate, well, if I have a rough idea of how much money I'm putting in this generic topic, and I'm getting this progress in my indicators, I should be able to get an idea of how efficiently are the resources being used. The problem is that there is a network of interdependencies. In the literature of sustainability, these are called interlinkages. And let me give you an example. Suppose there are improvements in public health, SDG number 3, and in infrastructure, which is SDG 11. Let's say that kids in rural areas now get their vaccinations, and they also have public transport, which can take them closer to the schools in shorter time. And because of that, the kids are going to perform better in the PISA tests, which are one of a piece of information used to build indicators on quality of education. So there's going to be improvements in education, not because of the resources that the government put in the topic, but because of externalities produced by improvements in other SDGs. Now imagine this, obviously this is going to opaque any attempt to supervise the inefficiencies of the policymaking process. And now imagine that this process takes place selecting across not only 7 SDGs, but I'm talking about hundreds of different development indicators. And these hundreds of indicators, they interact with each other in complex forms. So what we propose is a method that models exactly this process. And obviously for this, we're going to be inspired in these 3 aspects: that development is a multidimensional challenge, that the policies involved, these different dimensions, interact with each other in non-trivial ways, and that this gives place to a complex policymaking process. And it's a process that generates data that we see in the real world from a micro level to a macro level. So it's individual agents produce aggregate indicators that see in the real world. So our proposal to deal with this is a computational approach. We're going to simulate artificial agents that are policymakers, and we're going to put them to interact on a network of interdependencies between the indicators. This is going to allow us to simulate the data that we see in the real world about the indicators. So once we're able to match that data, we can infer some things that do not exist in the real world data, like the priorities that governments put across different policy issues. So let me give you a sketch of the logic of our model. The idea is that you have the government, which has some goals in mind, the little circle below. The government puts the resources to the policymakers. The policymakers transform those resources. The real world dynamics take place. There are interdependencies. The indicators change. But there are some incentives to being efficient. So the policymakers are going to learn how much inefficiency can be non-supervised by the government. So there's a learning process. Here is where AI comes in. So there is a behavioral model behind this. And the process is, the government is also learning about the performance and deciding whether it is worth to keep investing in certain topics that perhaps are not being the most efficient. So the government might shift and adapt. So it is an adaptive model. And if you think about it as a computational package, what the model does is if you have a set of development indicators for any country, you take those indicators, give it to the model. You have a network of interdependencies, and I can give you references on different methods to estimate those networks. There are many ways. You give those networks to the model, and then you give the goals or the aspirations that the government has in mind. For instance, the Mexican government published last month its National Development Program, which is the program to achieve certain goals in the next 6 years. And they have very specific goals. For instance, internet coverage. Their benchmark is 2017, we have an indicator of 85% coverage. And in 6 years, we're going to be at 97%. So it's that precise. So these are the aspirations of a government. So you give that to the model, and the model is going to simulate indicators as they reach those goals, and it's going to tell you, these are the priorities that you would develop, that you would allocate across this process. And we can also estimate other interesting things like the inefficiencies that take place at the level of each indicator, which also you cannot observe in real-world data. Now let me give you an example of a typical output of policy priority inference. And for this, I'm going to use some data. It's not exactly about sustainable developments because this was developed before we performed adaptation to the SDGs. So we're taking socioeconomic indicators only, not environmental ones. They are roughly 80 indicators. We're going to do this for more than 100 countries. These indicators are organized in 13 pillars, just like the SDGs. The World Economic Forum has 13 development pillars. And we're going to do two types of analysis. One is the retrospective one. So you have the data, and you simulate how the country went from its initial indicators to their final values. And we're going to infer the priorities. So what we're saying there is what the government has been doing during that period. And the other type of analysis that we can do is the retrospective one. So this is a kind of counterfactual analysis. We can say, well, suppose I want to simulate a scenario in which this country would have copied, would have imitated a successful country. So I want this country to reach the indicators of Canada or the US. Then we can simulate that, and we can tell you these would be the priorities that the government would develop if it would imitate effectively that development model. And a typical output would be this, would be, for example, this bar chart just showing you the distribution of resources. In a retrospective point of view, this is a hypothetical country. We have aggregated indicators across the 13 pillars, and you can see very clearly, for example, that this country developed more priorities to technological readiness than to public health, etc. What is more interesting is to do an exercise in the prospective form. So suppose we take the data from Mexico, and we say, well, what would be the priorities that Mexico would need to put in place if it would want to become Switzerland? So we take the Swiss indicators as the goals of Mexico and simulate Mexico getting there. These would be the priorities. The top priority is education, the second is public governance, research and development, etc. Then what if we change the goals of Mexico? What if Mexico would want to imitate Japan? You can see that there is some reordering of priorities. So this is very useful advice for countries who have certain goals in mind. What about if we look at another country, let's say Albania, trying to become Spain or trying to become China? You can see that the reordering of the priorities is more aggressive than in the case of Mexico. So what this is telling you is you have to think about three things when giving this kind of advice to countries. The first is we need to take into account who we are. So what is my network of interdependencies? Because that represents the socioeconomic structure. The second is where I am. Where am I? That is, what are my current indicators? What is my current state of development? And the last one is who I want to be. What are my goals? Am I really going to align to the SDGs? So now that I have presented you retrospective and prospective analysis, I can use those two to estimate policy coherence, which is a very popular topic in the policy community, in the international policy community, and yet we don't have methods to quantify it. So we're going to do that. And just to give you an idea how important it is, this is one of the first paragraphs of the Policy Coherence for Sustainable Development report from the OECD. You can see that the Secretary General mentioned some of the ideas that I have talked to you through this presentation, like not working in policy silence, interconnectedness between the different SDGs, synergies, trade-offs, which are positive and negative links, policy effects, etc. So what we do basically with this analysis, we're trying to assess whether governments are being coherent with what they want to do, with the goals that they want to achieve. This means we have somehow to understand what are their actions. And for this, we're going to use the infer policy priorities. And we're going to use the particular case of Mexico. This is a very good example because Mexico joined the OECD in the 1990s. And the argument was that Mexico wanted to become like the members that were already part of the OECD. So this is a prospective analysis. Mexico wanted to imitate those countries. And here for us, what policy coherence is a very intuitive concept. So you can estimate what Mexico has been effectively doing since it joined the OECD. That would be your retrospective analysis. Then you're going to estimate what Mexico would do if it would have imitated one of the OECD members, for example, Canada. Then you're going to compare the two priorities from those two analyses. If those two things are similar, that means that their actions have been similar to what Mexico would have been done if it would have really wanted to imitate Canada. So coherence is similarity between those two allocations. If they are very different, then Mexico has been incoherent. And this to give you an example. This is the result that we get for Mexico, trying to imitate Japan. On the horizontal axis, we have plotted the allocation of resources from the retrospective analysis, what Mexico has been doing. In the vertical axis, you have what Mexico would have done if it would have become Japan. If the two allocations would be identical, if Mexico would be coherent, all these dots would be in the diagonal line. Now, this is a very nice plot because you can see something here that is, if your dots are above the diagonal line, that means that you are overspending in topics where you should spend less. And if you are under the line, that means you are underspending. These are called allocative inefficiencies, a very important concept also in the community. Well, so because we can measure actually the distance from each dot to the diagonal line, we can build an index. And the index works like a correlation coefficient, goes from -1 to 1. If it is negative, you are incoherent. If it's positive, you have coherence. So we're going to do this exercise for Mexico, trying to imitate each country of the OECD. And we're going to ask ourselves, has Mexico been coherent overall? So here's the answer. On the horizontal axis, we have plotted the countries of the OECD according to their income per capita. And in the vertical axis, you have the coherence index for Mexico trying to imitate each one of these countries. The result is that Mexico has not been coherent. Not at all. Now, as a Mexican, this was not surprising, to be honest. But maybe I was expecting at least to have a positive correlation, because that would mean that at least Mexico has been doing the effort to be coherent with the most advanced nations, which is not the case. So very disappointing. And perhaps if you are not familiar with the Mexican context, this is not telling you much. But what if I tell you that we can also capture successful cases? So think about Korea. Korea joined also in the 1990s, the OECD. The argument would be very similar to the Mexican case. And we know that Korea has been successful, and also that Korea has tried to imitate Japan for many years. So in a similar plot, we would expect Japan to have a particularly high index. And this is what we have. Japan is at the top. Korea has been most coherent with Japan. And also there's a positive correlation. What about another case, Estonia? Estonia joined recently. It's a recent member of the OECD. Perhaps we wouldn't expect such a strong coherence as Korea, but we would expect that Estonia would be more coherent with the Nordic model, with the Nordic countries. It is well known that it has tried to follow their steps. Here you have it. Denmark, Finland, Sweden, and also Japan are the countries with which Estonia has been most coherent. And think that this is coming from an AI model on how the policy-making process works. This is telling you, this is validating our approach. It's telling you that our theory, the theory that we're using to explain the dynamics of development indicators, is capturing something that has been qualitatively, extensively shown in the field. So with this, I want to close, and I want to thank you for listening. I invite you to check out these websites where you will not only find the academic papers that the project has produced, but you will find also dissemination materials produced by the UNDP. So this is actually an AI tool that is endorsed by the official voice of the Sustainable Development Goals. And thank you very much.
Thanks very much. Thanks very much, Omar. We'll have some questions after the next speaker, so write down your questions and we'll come back to it. Our next speaker is Niamh O'Clery. Niamh is currently based in the mathematics department at the University of Oxford. She's also, and we're very proud of that, one of our Turing Fellows. And Niamh works on economic development in urban systems. I'm just going to invite Niamh now to join me to give a presentation.
Okay, so today I'm going to be talking a little bit about cities. It's one of my core research interests. And cities are particularly exciting to study for a variety of reasons. Internationally, we see extremely large levels of rural to urban migration. And these bring various planning challenges. So how to organize a city, how to adapt a city, and how to cope with things such as informal settlements in more developing contexts. So there has been an interesting and growing multidisciplinary effort, very much a collaborative effort to try to understand how some of the challenges that are presented in the urban context can be resolved. And alongside this multidisciplinary effort, there's been the emergence of big data. This is not a new phenomenon to any of you, but particularly in the urban context, the presence of a great number of different sensor technologies and different types of mobility technologies has enabled us to understand the dynamics of people in cities and various other quantities in very close to real time. So cities present a really interesting policy opportunity, not least because policymakers are particularly interested in these interdisciplinary efforts, the research inputs that come from the diverse set of fields, including data science. Okay, so as part of the scientific push to understand cities over the last couple of years, there's been an effort to try to see if there are some universal laws that are at the foundation of the dynamics of cities. So I think the phrase that would sum up the foundational thinking behind much of this work is that a city is very much more than the sum of its parts. There's something special about cities, and cities are able to generate more, particularly from an economic perspective, they're able to generate more output than would necessarily be expected, particularly with respect to city size. So on the left-hand side here, we just have a very simple plot of population in cities against the number of patents that the cities produce. And we see across the world a conserved, what we're going to call a superlinear relationship. So the number of patents scales more than proportionally with city size. So larger cities produce on average many more patents than you might expect. So this superlinear behavior is actually present across a large number of economic indicators, suggesting that there's something about cities that is very powerful in driving interactions that are at the foundation of economic productivity. And so we just see on the right-hand side here a couple of those other economic indicators that we observe that scale superlinearly with size. So in this particular talk, we're interested in one of the foundational questions of urban economics, and that is, why do firms and industries choose to cluster in cities? Why do different cities specialize in different types of economic activities? And what are the driving factors behind the decisions of firms to cluster with other industries and other types of firms? Okay, so this question has been around for quite a long time. And in the late 1800s, Alfred Marshall suggested that there were three main channels or factors at play. The first one being labor pooling, the idea that firms industries tend to locate with other industries that share similar skills. And so this is just a graphic that shows you in Manchester. It's a cluster of textiles firms together with online textile and clothing retailers. This is an example of a cluster of firms or cluster of slightly different industries that have chosen to locate in close proximity in order to benefit from a shared skill pool. Many of you will be familiar with the US expertise in producing cars. So this is just the kind of automotive alley, so to speak. This is a plot of assembly plants and locating in close proximity to their suppliers for the production of cars. So this is just an example of the second externality, the idea that firms tend to locate close to their customers and their suppliers, particularly industries that have higher transport costs. And so the third externality is slightly trickier to quantify, but it is this idea that firms choose to co-locate in order to benefit from knowledge spillovers, that they want their employees to interact, and that is the kind of the idea flow between industries that generates these externalities. So here's a sort of plot of some of the big tech firms in San Francisco who've clearly decided to locate in close proximity to both probably benefit from a very relevantly skilled labor pool, but also to benefit from this idea of there being sort of ideas in the air, in the mist. Okay, so one of the key research questions that has been around for a while is which of these externalities is the most powerful in general, on aggregate across a wide range of industries. And so because each of these externalities gives rise to a very similar prediction, the idea that industries will cluster in space, it's been quite difficult to disentangle from an empirical or a data-driven point of view which of these externalities is the most important factor. And so relatively recently, there was a paper by Ellison Glaser Kerr who took a sort of what I'm going to call a sort of industry pairing approach. So they tried to look at the relationship between the co-agglomeration or the co-location of industries with each of these different channels. And we're going to discuss in a second how each of these different linkages were derived from data. Okay, so the key idea here is that we want to look at patterns of co-location of industries. So basically the linkages between industry pairs, and this linkage or this edge weight here corresponds to the propensity of these pairs to co-locate in space. And then we have a similar metric which quantifies, so in the first case, in the case of labor sharing, we can quantify the propensity of firms to want to share labor in terms of their occupation demographics. We have very good data measuring customer-supplier linkages between industries. And then finally, we can use patent data to estimate the importance of this sort of knowledge sharing between industries. And so the key idea of these papers is that we want to try to estimate which of these channels is the most important driver of firm co-location or industry co-location patterns. Okay, so I'm not going to go into too much detail, but the key takeaway fact here is that we can use this type of linkage data in order to estimate the strength of the relationship between co-location patterns or agglomeration patterns and each of these externalities. And along with some co-authors, we estimated the strength of these relationships over time. And so what we observe is something that you might expect, is that over time, co-location patterns are increasingly driven by labor linkages, right? So firms increasingly care more and more about getting access to the relevant skills that they need, and value chain linkages, transport costs, as you might expect, have decreased in importance over time. So this supports our sort of key idea that when firms choose where to locate, which city to choose, they're most interested in the type of skilled labor, the type of sort of embedded know-how there is in the local workforce. And so that prompts us to investigate more the dynamics of labor relations between industries in general. Okay, so I'm going to talk a little bit about a project that I did with the Irish government, where this is exactly the kind of question that we were interested in. So, as many of you might be aware, Ireland, of course, is kind of well known as a Celtic Tiger economy, but at the same time, it's quite fragile. It's been prone to quite a few different sort of boom and bust cycles. It's a very high-tech and services-oriented economy, but as many of you will probably be aware, we have a very high proportion of foreign multinational firms. So as a percentage of GDP, it's quite staggering. And so some previous analysis that I have done with some collaborators suggests that there's actually a worrying distance in terms of skills between foreign multinational firms and domestic firms. So effectively, the types of activities that foreign firms are engaged in are not really connected in terms of the types of skills and knowledge that they use as domestic firms. And this is very worrying from a policy perspective, because one would hope that some of the knowledge embedded in the foreign multinational firms would actually diffuse to the local economy and perhaps be instrumental in sort of raising the sort of sophistication level of some of our domestic firms. Okay, so we can study some of this knowledge dynamics between industries by looking at the patterns of worker flows between industries. So effectively, the data set, our sort of key data set here, is a data set that maps transitions between, of workers between industries. And this is going to enable us to probe, in a sense, the structure of knowledge mobility within the Irish economy. Okay, so the linkages that we previously discussed, right? So these linkages between industries, and here we're measuring the strength of the linkage in terms of worker flows. We can represent these linkages as a network. So here the nodes are industries, and the edges are the number of workers that switched between industry pairs. So this is effectively a model of labor mobility between industries in Ireland. And so what's interesting here, so here the nodes are sized by employment. So we see on the left-hand side, we see that most of the employment is focused in these quite clustered regions of the network that are really focused on services. So finance and the public sector, and we have retail and hospitality there in the bottom. Here the nodes are colored by sector, and we see that the sector classification doesn't really capture very well the structure of the network. In fact, we have a lot of grouping of industries. So if industries are located in close proximity here, it means that they tend to exchange a lot of workers. They exchange knowledge, and they're very connected in terms of skills. And so we see, this is just another visualization that basically shows the degree of worker mobility between sector pairs. And we see that there's extensive mobility off the diagonal, which means between different sectors. And so we need to employ a different type of, we need to employ some data science analysis techniques in order to quantify the clusters that we observe in this network. Okay, so the approach that we're going to take is that of community detection. And the idea here is that we're just going to apply this algorithm in order to detect groups of nodes. So that is groups of industries that are highly connected within the industry network. And the idea here is just to let a random walker, so we just have a walker, and that walker is allowed to roam on the network and jump from node to node. And this walker will become trapped in regions of the network where there's high density and high levels of connectivity. So this is just the general idea behind this type of community detection algorithm. And the longer that we let the walker roam on the network, the larger the communities that the algorithm is going to find. So we have a sort of parameter that we can control, which is the time that we allow the walker to roam on the network. And longer times are going to correspond to larger communities. Okay, so this is just a visualization of the network for one specific time. So this is just giving us a sense that actually this algorithm, so the nodes are now colored corresponding to the communities, the node grouping that we find. And we're assured by looking at this diagram that in fact this algorithm is capturing better than the official sector classification, the groupings of nodes, so the industry clusters in the data set. And so as I mentioned, we have a time parameter, so that's on the x-axis. And as we let the random walker roam for longer on the network, if we look at the blue dots, we see that the number of communities decreases. So we have fewer but larger communities. And we have another metric here, which I'm not going to go into too much detail about, but the variation information effectively is a measure that captures how robust the community partition is at that particular time. Okay, so here we have a visualization of the communities for different characteristic times. So the first thing to notice is that as the time gets larger, we have larger communities. And one of the very interesting features is that we see this natural division of the network for large times into two, which basically chops the manufacturing and retail sectors off from the high-tech services. So this, in a sense, is we've discovered in our data this divide between services and manufacturing, which is something that many of you will be familiar with from the news cycle. So we can visualize this process of merging communities into larger communities in the form of a dendrogram. And this is basically starting off on the left-hand side with a set of rather small communities and showing that as the time increases and the random walker walks for longer on the network, we merge these communities. And the interesting point here is that communities that stay distinct for a long time, they resist merging, right? They're very isolated. They're very disconnected from the network. Those communities are very well formed. So, and this particular plot can tell us which types of sectors are very isolated in the Irish economy. They exchange workers within the industry cluster, but they're not connected to the rest of the economy, which has repercussions for a number of different things that we're going to see in a second. So we see here that the public sector and finance remain distinct for a very long time. They are only forced to merge with the other sectors at very late times, which means that the public sector and finance in particular are disconnected from the rest of the economy in terms of knowledge exchange and skill overlap. Similarly, the farming and food sectors at the bottom are quite late to merge with the rest of manufacturing and construction. So we see this kind of hierarchical decomposition of our industry network, which gives us quite a lot of information on the structure of knowledge flow and worker mobility in the Irish economy. Okay, so what are the implications of this analysis? So our analysis has extracted from data groups of industries, so our communities, that are effectively, we can see them as knowledge clusters. These are groups of industries that tend to hire from each other, and some of these industries are very disconnected from the rest of the network. So I think a particularly interesting case in point is finance. So finance is, as we've seen, it's quite disconnected from the network, but it similarly has a very large employment size. However, if a new finance firm is moving to Ireland, for example, and they want to hire, the amount of labor that's available, skilled labor that's available to them in industries that are related, that exchange workers with finance, is very few. So on the y-axis here, we have the ratio of labor, of employment that's available to an industry as a proportion of its own industry employment size. So this is, in a sense, this is a little bit worrying for the finance sector in Ireland because there is a very small pool of labor from which they can hire. And so this has implications for industrial policy. And it actually turns out in the literature, and we also validated in this case, that the size of available labor, so this labor in related industries, is predictive of the potential of the industry to grow in the future. Okay, so one of the key interests of the Irish government from this project, and it's something that we haven't completed our analysis on, but I just thought I would mention it, is the impact of, so as I mentioned earlier, it's quite concerning that foreign multinationals are quite distant from domestic firms. And so what we want to do here is actually quantify the movement of people from multinational firms to domestic firms and try to understand if there are any productivity gains for those domestic firms that are recipients of these workers. And so the literature would suggest that there should be, but in the Irish case, the evidence is limited. And that's sort of where this research is going at the moment. And finally, just to mention a new project that is being funded by the Alan Turing Institute in association with the Office of National Statistics and HSBC, and it is to build this type of labour mobility network for the UK, and to use it to try to understand the resilience of UK cities in terms of their ability to redeploy or reallocate their workforce in response to various pressures. So the key idea here is that, if you are a UK city and you have many connections within this labour mobility network, then you have many options. If there's some kind of pressure, such as automation or Brexit or climate change, and over either a shorter or longer period, you need to effectively reallocate your workers from old industries to new industries. The structure of this network will actually be informative in telling us which cities are better posed or better positioned to reallocate their skills into new industries and be sort of more agile from a sort of skill perspective. Okay, thank you very much.
Yes, I hope you've been writing down some of your questions. We're going to have a little panel session now. I will attempt to chair, so bear with me. And I'll kick off with a few questions, but I will, because we haven't done it so much in the previous sessions, we'll give you a chance to ask questions to the panelists as well. So I think you've given some great example of how data science and I wouldn't say AI perhaps in this case, but how data science is applied in a policy context from a research perspective. And maybe starting with you, Omar, you know, in your experience, you know, how kind of policymakers globally right now are kind of using this kind of techniques, AI, machine learning, in perhaps in developing policies or perhaps in monitoring the effectiveness of policies at the global level?
Yes, well, if we think, for instance, in the United Nations system, they have been quite open to these technologies for a while, especially when it comes to disaster management, right? All GIS, spatial modeling. Recently with the Ebola outbreak, they were using really sophisticated methods of contagion networks. But when it comes to perhaps more economic topics, this is unexplored territory. And in particular, for instance, for the SDGs, kind of a holistic approach to advise countries, there are no methods that really do this in this fashion. And the reference that I can give you is that the UNDP has a website where they have collected all the methodologies available to advise countries on SDGs. They have done this under mandate of the General Assembly since last year. And you will find there that you have a wide range of methodologies going from anthropology to kind of system dynamics, which is a technology from the 60s, but it's not really AI. So they are just starting to tap into this technology when it comes to the SDGs.
And perhaps the next question is for you, Neve. One thing that seems to strike a strong message here is that data science has the potential to disrupt the way economics is used in the context of policy making. Can you give us a bit of a flavor of how much of a disruption this is causing right now, or is likely to cause?
Yeah, I think that's true. I think that, I think particularly in economics, there were some very clear failures of the discipline to predict some of the recent crises. And I think that combined with the new availability of big data and the greater awareness of the potential and tools available has really opened the eyes of policymakers who are genuinely really interested in on the one side, usually the interests are relatively short term in terms of what is kind of the next policy agenda, but on the other hand are very, very interested in understanding what is the best thing to do without too much regard to a disciplinary slant. And so my personal experience is that policymakers are extremely open to engaging with people from all types of different disciplines, particularly data science. And I think that the key challenge there is that when you're applying slightly more sophisticated techniques, it takes a little bit of time to be able to explain those in a simple enough way in order to give the policymakers confidence, in a sense, that to interpret the results. But I think generally speaking, there's a huge potential and appetite there. And I think in terms of disruption, I mean, certainly there is, and I think there's some tensions on various levels. I think that data science tends to take a very high-level aggregate view on sort of thinking at a sort of what can we observe at the city level. And I think in many other disciplines there's a tendency to think at very local levels and to think that you're missing a lot of nuance if you're kind of trying to find patterns in sort of higher-level data. So I think that the next challenge in a way is to try to integrate better those two perspectives, particularly more qualitative social science alongside big data science, and to try to, rather than have those two things compete a little bit, to try to think about how we can take data from different scales and try to come up with more holistic or more rounded insights, rather than have the two kind of come from very separate communities.
Thank you very much. I think it's time to open the floor for questions. So we have a roving mic over here. Is anybody wants to ask the speakers a question? Don't be shy.
Hi, thank you. A question for Omar. I'm almost worryingly excited about your research, and it's a very straightforward question. What is next? What's on the roadmap? And also in terms of funding for these type of projects and your ability to scale. Thank you.
So let's say that the version 2.0 of PPI was what the academic thing that we developed. Right now we are developing the 2.0, which is turn it into an SDG tool. Like the transition was, before we were only looking at socioeconomic indicators. We tend to interact in a positive way. You know, if GDP grows, education probably is going to grow as well, equality. But when you introduce environmental variables, then you have negative relationships, and then it's a bit tricky. So we did that adaptation. And the next step, 3.0, is to link with the growing trend of open fiscal data. So there are countries that are starting now to publish the data that I say it doesn't exist yet. A couple of countries are doing it. We're working with the organization that is pushing for this agenda, and that's going to take this to a whole new level. And in terms of scaling, well, the UNDP is doing their part there, and they are basically bringing this to different countries. So we started with Mexico, but we are growing already to a couple of more countries to disseminate this methodology.
Questions over here? Yeah.
Again, a question for Omar. Thank you. You mentioned the UN use of this in the Ebola response. And I'd just like to hear a bit more about how the UN used these data and what they did with it.
So it's not exactly my field, so probably I don't have too many details. But from the last time that I went to New York and I spoke with Pedro Concensao, which is he's in charge of the Human Development Report. He said that when the outbreak happened, they called the top experts in the top labs that analyze epidemiological outbreaks, and they'll have these huge simulation frameworks in which you have data on airports, for example, air traffic, and then you simulate how, like, counterfactual scenarios and outbreaks and what measures could stop it.
Next question. As you're still thinking, I'll ask, oh, sorry, one over here, sorry.
I guess a question on the policy implications of the cities analysis, whether it implies that cities should collaborate with each other or better off competing. Yeah.
I think that will really depend a little bit on, so our analysis aims to quantify the extent to which cities are able to redeploy their skill base based on sort of existing connections between industries in a sense. So in terms of, in some cases, it may be better for, so in some cases it may be appropriate for a city to kind of specialize but also to think about linkages, right? To think about building linkages, and there's different ways to do that. So one of the ways would be to collaborate. There are different ways of importing skills these days, whether it be via using sort of online labor markets, or thinking about specific training to build linkages between industries. So I think about it a little bit more on a skill-specific level. And so I think the key thing is that, and one of the quotes I had on the screen is that there's a huge data deficit in the UK. We really don't know who is good at what, and that's something that's really only, I mean, it seems like a very fundamental question, but we really don't know which places are well specialized in what type of industry and what is the sort of local skill base. And we do know from the sort of international literature that what you currently do now constrains what you can do in the future. And so that's what this analysis is trying to get at. It's trying to get at those linkages that both think about what is possible and think about what's your kind of exposure. In the sense, it's almost the converse, what is not possible. And if we can identify some particular pressures on industries, then we can think about quantifying the ability of a city to respond to a shock. And so it's building those linkages. There are a couple of different ways of doing it. But in many cases, it will be about collaboration and building new linkages, but there are a variety of ways to do that. Yeah.
Okay. So whilst you're still thinking of other questions, I'm just going to ask one to you, Niamh. To what extent the Irish government has kind of looked at the results from your research, and if they have taken notice, which I hope they have, how they're using those results, and how, what changes are they making?
Yeah, so it's actually been quite an interesting journey. So I was a postdoctoral research fellow at the Harvard Center for International Development, which some of you may be familiar with. It's led by Ricardo Huisman, and they've developed some very interesting online mapping tools, really at the country level, to understand diversification. And so while I was there, I was involved in running some workshops for policymakers from different countries. And at one of the workshops, there was an Irish policymaker from what was then Forfos, which is now the Department of Jobs, Enterprise and Innovation. And we just got chatting, as you do. Always, if you meet an Irish person abroad, you go and say hello. And long story short, he said, well, we would be really interested in applying this analysis to Ireland. Would you be interested in doing a short consultancy? So that was quite a number of years ago, in about 2014. And so I basically, at that stage, applied this. It's analysis of export competencies. And it was that initial analysis that identified this big kind of skill distance between the exports of multinationals and domestic firms. And so that actually kick-started a long-standing relationship with them. And we're actually on the third phase of that now. So the second phase was analyzing this labor mobility structure. And we have some really interesting conversations. I presented this sort of around about this time last year in the department in Dublin. And what I really find interesting when I meet with policymakers is the insights that so you show them an image, and for me it's a network, and I don't see anything very special about a specific node, but they will really zoom in on a node and look at its connections and say, well, we know that's a specific huge multinational laundry company, and that's got all these connections, and that's really interesting. And they have a lot of anecdotal evidence in their mind that they're trying to kind of map to the data. And so I find bringing the results of your data analysis to policymakers kind of almost brings it to life, because they have so much kind of background knowledge, and they've got so many kind of working theories of what's going on in the economy that they immediately try to interrogate your data. And so we actually, very recently, we are just actually signing a new collaboration agreement where they have hired actually 2 economists inside the department, one of which is going to be seconded to the statistics office to gain access, because this type of data is very difficult to gain access to. It's data on individual workers, so it's quite tricky. And so we actually have to have somebody working in the statistics office in Dublin. And so this third part of the analysis, which is really concerned about looking for productivity spillovers between multinational and domestic firms, is actually going to be which is actually, to be honest, a little bit intimidating. It's going to be the main research input into the national job strategy. So it's kind of, it has started off at a fairly, consultancy, quite a low level, and has built up over quite a number of years to be quite a very strong collaboration. And so I'm based in a maths department, so I think on both sides this is somewhat of an unusual, unusual partnership, but it's one that I hope continues and is fruitful.
Fantastic, thank you. Question at the front.
Hi, my question's for Omar. I suppose the quality of your model depends entirely on both the inputs and then the quality of the indicators you're using. And so how do you deal with that, especially if you're dealing with sort of countries that have lower quality of data inputs in the first place?
Yeah, well, like with every empirical tool, garbage in, garbage out. But an advantage that it has over other approaches is that you don't really need to rely on enormous amounts of data. So to give you an example, the typical advice of a consultant from the World Bank would be, give me your data, I'm going to run a regression, I'm going to explain GDP in terms of other indicators. And many times, the amount of data that a single country has is not enough to consider 10 indicators, because this data is very coarse-grained, like you collect it annually. So then they combine data from other countries together, and then they run the regression. And what's the problem there? That then the advice is not anymore about that country. It's some hypothetical country that represents all that mix of countries. Our method doesn't have that limitation. We actually don't rely on the tools that econometrics rely on. So, of course, better data, better outcomes, but it does have important advantages over other approaches.
Any more questions? Yeah, just at the front.
Hi, this is also a question for Omar. I was wondering, with the direct sort of comparability approach of this economy to that economy and what could lead to improvement using another economy as an indicator. I was just wondering if there, particularly through the UN, if there are any sort of political interpretations that came from that in the way, I don't know, countries asking advice, we're looking at like, oh, that particular country, and whether, I don't know, any international relations kind of contexts were considered in people's response. That's all.
So I'll divide the answer in two. So first, the comparisons. The nice thing of having these networks of interdependencies is that if you have them for each country, that basically captures the context of each country. So in that way, you can do certain comparisons. Of course, you have to take care of having the same indicators. Depends how good of a comparison you want to make. Then in terms of political stuff, we try to leave that outside. And if you see, there are 3 inputs to the model, and one of them is the goals, the aspirations. And that may come from different agreements. It can come from a societal agreement, it can come from really following an international agenda, or it can be a completely discretionary determination of some authority. So we're agnostic about that. So as long as a country has some aspirations, the model will just do its job.
Okay, any more questions? Oh, yeah.
Hi, this one's for Neve. I was just wondering, you mentioned a couple of times that it's really difficult getting data on individual workers, and that was part of the reason you couldn't carry out your research in the UK. And I was wondering, is there significantly more data available on Irish workers than on UK workers?
Yeah, so that's an interesting question. So in Ireland, there are data sets. Well, effectively what we have access to is so it's held in the Central Statistics Office. It's very much under lock and key, and you have to go through like a lot of different processes to get access. Actually, I've never personally seen the raw data. I've always had a government statistician work on it and export high-level aggregates. So in Ireland, there's basically every firm files a list of their employees, and we can actually map those firms to industry classifiers, and so we can actually look at this data set over time. And so basically, effectively what we want to do to create our underlying data set is to count the number of workers that transition from one to another. So it's fairly simple. In the UK, actually, that data is, I think, what we need is a longitudinal data set, right, where we see the same worker over time in order to capture these transitions. And actually, in the UK, that is not available to researchers. So the HMRC does have this type of data, but it isn't available really at all to researchers in the way that it is in Ireland. And so we have a 1% sample in the UK, which will enable. And so this is a longitudinal data set that has specifically been, sampled or designed in order to let researchers do kind of longitudinal analysis. So we just have a 1%. But at the same time, because the UK population is so large relative to Ireland, we still will be able to get some relatively robust patterns. But I think in the future, there is some sort of slow movement towards opening up these much larger data sets. And so certainly having worked on this 1% sample will put us in a really good position to kind of bid or lobby a little bit to try to get access to these much larger data sets at a later point in time. But personally, as of now, I've never spoken to anyone or heard of anyone who has had access to the full data set. People have had access to slightly larger randomized samples, but not ones that are trackable over time. So they might have a 10% sample, but it's changing. The 10% is changing every year, which is actually not helpful for us. So it is all about the details, but actually it varies quite a lot in different countries what different researchers have access to.
Okay, I think one last question. Final question.
Thank you. Earlier at the impact stage, Professor Diane Coyle, she briefly mentioned that despite one of the challenges public policymakers might face is that regardless of their efforts to use data science to inform policymaking. Ultimately, whether the policy gets actually adapted to society is down to politicians. And I was wondering if you agree with her that that's one of the challenges, and whether you might have any thoughts on how to address the challenge.
I can start, and then I guess Omar. So I guess Omar and I have had experience in policymaking on slightly different levels. I've been more at the national level, and Omar maybe slightly, especially this presentation, is more at the international level. So I can speak to my experiences. So I think the first thing to mention is that it's not a case, so my experience, and I think that of my colleagues, it's not a case of designing. So I guess the impact agenda is very helpful to think about how we go about devising research that's useful for policy. And one of the key things that, especially since I've moved back to the UK from the US, that has really resonated with me is the idea of getting policymakers on board from the beginning, right? So the idea that actually, we just started this project that I mentioned with the Turing Institute. And so we actually have spent, this week and Monday, we were in Manchester meeting with policymakers, and we haven't even got the data yet. And it's because we want to get them on board from the beginning and actually say, this is what we're planning to do. Is this going to be of interest to you? What are the key policy, especially the timing, what are the key policy decisions that are coming up in the next couple of years that this could be informative for? So actually understanding the landscape is, I think, the most important thing when it comes to research and policy, is that actually policymakers have agendas, and the agenda is somewhat known, so it's very important for you to go and speak to policymakers really early and find out what is the agenda for the next few years, because if you come with something that actually was already decided last year, no matter how interesting it is, it's unlikely to make an impact on that agenda. So, and also it takes quite a long time to build relationships, right? So, for example, in Ireland, as I mentioned, it took a very long time for me to build up to a relatively high-level relationship, where now I actually speak to the assistant secretary, right? But at the beginning, I was more a sort of, outside consultant, and so that is a long process that takes time. So in the case of the Turing project, we actually brought on board somebody into the project team who has a lot of experience working with UK policymakers and a lot of connections already. And so she's been kind of facilitating that. So I think it is that process. It's definitely not a case of doing a piece of research and then trying to kind of farm it around to different potential policy partners. I think that's rarely successful. You have to really get on board early and develop a relationship over quite a number of years. And I have to say, I haven't really been yet involved at the sort of political level. I'm sure that's something that will come in the next few years. But as I said, I think that's more a function of how long it takes to kind of, to kind of embed yourself in that process. So as I said, in the Irish case, we're kind of beginning to kind of peek into that level of decision making. But I think it's something I probably might be better able to answer in a couple of years, actually.
So in my case, it has been quite interesting because the UNDP, as an international organization, is very keen in involving the stakeholders in the process of funding any of these projects. And for the project of Mexico, we're actually doing it at the federal level, but also at the level of 2 states. Because in Mexico, by law, not only the federal government has to publish a development plan when it takes office, but also every state, whenever there's a new governor, with very specific goals. And for example, Niv was mentioning that sometimes the policymakers already have an agenda set like a year ago or so. So our problem is our project is interesting because you can actually manage both things. So in this case, they already have the agenda. We entered when the new government took office, so they already had the goals. So now it's a question about how do we get there. But then the idea that the UNDP wants to develop is that we use this tool to actually, when a government is just taking office and is figuring out what is going to be the agenda, perhaps it knows already 2 or 3 topics, but not hundreds of them, then they can use the tool to identify where there is more potential in order to have a realistic agenda. And what has been very, very interesting in this activity is that we have run workshops with these stakeholders, with representatives of the different offices. And they have been part, for example, in activities like in our framework, you can differentiate between indicators that actually have policy instruments that the government can directly intervene, and indicators that you cannot really directly intervene, but they move because of the network of spillovers. GDP is an example. No government would tell you that they have an instrument to really affect GDP directly. It's an aggregate indicator of many other things. And in that activity, the stakeholders can tell us a lot. Oh, in my experience, I know that there is a policy instrument for this particular indicator. In my state, there is for this. In my other state, there isn't for this. So they really get engaged with this project. They really feel part of it, and it has been quite interesting to develop it together.
Okay, I think we need to close now. It's a big thank you to Niamh and Omar for such great insights into the world of policy. And thank you all for making the time to come this morning. And I know it's cold, and I know everyone wants to move on and probably have some food. Because it is the last session of, the last kind of speaking session, it's important to kind of actually thank CogX, thanks the sponsor, thanks all the staff and the volunteers and the exhibitors who've kind of helped make this 3 days just a wonderful event, and I really hope you've enjoyed it. We certainly have, despite the weather. So there is a hackathon at 2 o'clock. If some of you are involved in that, I don't know whether many of you are, but if you are, you need to come back here for 2 o'clock. But otherwise, again, a big round of applause for our speakers and to you all.